Well, good evening, everybody, and we are back with another show. This time we are with Professor Phil Bell, and he has come up with a unique idea called, being an honorary flat earther. We'll see how it goes. I'm not too sure how the format's going to work out. He's got something planned. I'm sure it'll be quite interesting. I hope it goes all right. And just bear with me whilst we go through this. So, as you can see, this is called on screen, Flat Earth Episode 1 with Professor Phil Bell. As you can see his little avatar, he sent me over that. So let's just do a little mic check and check that you're there. Professor Phil Bell, can you say hello to everybody?
Yes. Hello, Ranty, and hello, everybody out there.
Yeah, you're coming through fine. That's good. So let's explain. Professor Phil Bell is a globe earther, as you know. He has a lot of videos on his channel explaining how he believes that the Earth is a globe. Of course, we're at the opposite end of the argument here. From our side, we believe the Earth is flat. He's a globe earther, but what he's come up with, something unique. Do you want to kind of tell the audience what it is that you've got planned for us this evening?
Okay, so what I've suggested is going through. I've got a bunch of paragraphs, probably around about 25, 26 of them. And the idea is to have a look at the arguments that the ballers are making, and because for today I'm a flat earther, and I'm going to have a look at the arguments that the ballers are making and see what part of those arguments we can reach some sort of agreement with, or throw out, or change ourselves so that we can actually we can cause them to have less arguments against us. In other words, I want to be able to knock most of their arguments out cold. So that's the point of this. Of this. And let's see if we can't actually start putting the makings of a model together. Right. So my argument is that we need a model. We should have one, and we can't expect the rest of the community, the rest of the world, to take us seriously if all we can ever say is the Earth is not a globe, but we don't know, we don't care, we're not even going to try, we don't have a model, we don't intend to have a model, no one's going to take us seriously. So I'm saying that we ought to start putting a model together. So let's have a look at the framework from which we can do that. And one of the ways to do that is to knock cold some of those arguments that the ballers have.
Okay, so well, firstly, what I would say is that I think if you ask any true flat earther, because obviously you're an honorary flat earther for this evening, so you've got to understand it from a flat earther's perspective, which would be that essentially we don't need to have a map. We don't need to have that assurance of being able to go to a model and say, this is our model, this is how it works. Because, and I'll say why, is essentially we don't know where we live. Everything that we know that water lies level, we know we can see too far. We know that the model we have been presented with as the globe is broken and it doesn't match reality. And that's what we do know. One thing we don't know is we can't put our finger and say, this is where we live, and this is the extent of our realm, because we just don't know. So, from obviously from your side of the argument, being a honorary flat earther, you would like to see a map or a kind of model to fit in with your belief of, because you have a model and a map, even though you're trying to be a flat earther, but you're a glober. It's very difficult, but flat earthers don't necessarily need a model, but I can see where you're trying to go, so we can definitely move on. But as long as you understand that for a flat earther, we don't necessarily need a model right now. We can't go beneath 60 degrees south latitude, so we don't know how far this extends. We don't know the confines of where we are. We're not allowed to explore.
Okay, well, my argument is on that, and say why we need a model. Let's say, for instance, you want to go from Edinburgh to London. I mean, you need to know where these two places are. You need a map to be able to decide to be able to travel between those two cities.
Yep.
I mean, at the moment you have a map, and this map is, if you like, provided by the globe people. But
however, can I just stop you there for just a second and say that the greatest maritime, or probably two of the greatest maritime countries, let's say France and possibly Holland, but basically the UK. So there's three maybe, but you're looking at basically France and the UK. 1700s, 1600s, 1800s. You know, back then, everybody knew the Earth was flat, and they were able to navigate using maps and the stars based on a flat map. They didn't have the globe. In fact, the globe Earth in the 1900s was, sorry, the start of the 1900s was tried to be taught in the UK, and the guy was taken to court over it because it was heresy. And I mean, you need to understand the history of what was taught in the education system in the UK. So if in the early 1900s it was still being taught that the Earth was flat, and yet we had the greatest maritime armada that was able to circumnavigate the known world to a T and conquer it using flat maps, that doesn't really sort of like go well with what you're saying about the globe argument for now.
Well, look, I think what you just said is terrific. All I want to know is, where is all that information that they had? Because let's bring it back. Because it's sure as hell, if they got around, they did get around. I mean, Captain Cook did arrive in Australia. We can't deny that. I mean, he didn't magic his way back over here to Australia. He sailed here, and then he sailed all around this area, and even all the way to Hawaii. So he didn't do that by magic. He obviously had charts and maps and stuff like that. So why don't we find out where are they, so that we can start putting them together and say, look, here is our map.
Mm-hmm.
So this leads me onto this onto the first one, and I'm saying this.
But just in answer to your question, though, just so that sure. So that we sort of clear that up, is that back in the 1900s we had a flu pandemic. We had World War One, we had World War Two.
Yep.
We had a lot of changes that went on, a lot of things that were quote unquote burnt and lost. History will. I mean, you'll struggle to find any kind of book more than 250 years old. You'll struggle to find one, and if you do, it's likely in a museum or something like that. Yeah, there were books 300 years ago, 400 years ago, but we just don't have them. A lot of them are locked away, especially in places like Rome, or just burnt, just rid of. So history for us is really difficult because we're only provided with the history that the controllers want us to see. And as a flat earther, we understand this, that it's unlikely we're going to find maps from 500 years ago that are just going to fall out of a book somewhere. It's very, very unlikely because they've been found and they've been destroyed. So we appreciate that. We know how this has panned out in the past. So anyway, so carry on. You had something.
Well, the main thing is that, I mean, a lot of that information is still available in London. I mean, all of Captain Cook's voyages, his command. I mean, he wasn't a merchant seaman. He was a Navy lieutenant, and kept meticulous records. Most of them are still intact in London. So people can go and have a look at those things if they want.
But is that the only book or map or anything of the time? I mean, what happened to all the rest?
Well, I to be honest, I don't know. I mean, I'm a scientist. I'm not a historian, but I do know, because I mean, obviously I've learned about Captain Cook and where his records are. Where these things can be seen, and they most certainly can be seen in the museum in London. But not just him. I mean, there's Wellington. There's quite a few, and then of course the Danish people were also big seafarers. They also have kept records, even records kept by Vasco da Gama and people like that. who sailed around South America and then Africa and found the route to India. Those records are also still intact.
Do you know how many miles Captain Cook sailed trying to circumnavigate Antarctica?
Well, I mean that's as far as I know, I have had a look at the actual route that he took, and most of it was there was part of it was Antarctica, but most of it was just sailing around the South Pacific, and spent a lot of time in places like Hawaii and French Polynesia. So he went backwards and forwards several. In fact, he did 3 voyages. There was no. I don't believe there was an actual complete circumnavigation of Antarctica, but I could be wrong. Like I said, I'm not a historian.
There wasn't a circumnavigation of it because he wasn't able to get around it. What happened was, I think it was over about 4 years, if I recall correctly, and I believe it was about 69,000 miles that they travelled. So they tried to get around. But
that was all together from England.
Yeah, and they tried to get around. Well, what's the circumference of the Earth in the globe model? I mean,
but it included his 69,000 miles included going backwards and forwards many times.
No, in
the South Pacific.
No, it included heading to the Antarctic, trying to sail around it for 4 years, and then heading home.
Well, I mean, it's easy to find out. I mean, we can just bring up a map and the map's based entirely on his very, very meticulous logs. So
I can assure you
look at it.
I can assure you that the circumference of the Earth is not 69,000 miles.
No, absolutely. I have to agree with that. Although, I mean, we don't know that. Again, even you and I both saying that, we don't know that. I'm a flat earther today, so I don't know, because I don't know how far out it goes out. I've got no idea, so I can't really say that. I can say that if I was at the equator, just based on the equator, and if I accepted a map, if I accepted any kind of map that looked anything like the AE map, then I would have to agree that the equator was about 39,000 circumference. So it would have to be in the 70s, 80s at least, around by the time you got as far as Antarctica. So yes, it definitely would be that far. So that's if you accept that a map that looks anything like the AE map. But I'm not. I'm saying lose it. I'm saying that the AE map, as it exists now, lose it. It doesn't work.
I have to agree.
Everybody knows it doesn't work.
Well, no,
yeah.
I wouldn't say that everybody says that it doesn't work, but it is a representation. Yeah, I will agree that technically it isn't correct, and then again, the globe isn't either. I mean, if you look at the sizes of the continents that are shown on the globe, they are totally disproportionate to their actual sizes. I mean, if you look at the size of Greenland, for instance, I mean, that country is so big, but it's not really.
Yeah. Look.
And yeah, so I think the AE map is just a projection of an idea rather than it actually being technically correct, because again, it's very difficult to map this stuff out with the limited abilities that we have as flat earthers. I mean, we're very constricted to how far we can travel. We're very constricted to the type of travel that we can do, the funding, etc., to actually find this stuff out. So from our perspective, and also history's been hidden. All the maps in the past, the people that have actually documented this, a lot of that's been, that's lost to history. So we're starting afresh, basically.
I'm not disagreeing with you at all, Randy. I agree with you. All I'm saying is that yes, you can keep the AE map as an idea, and say, well, look, we don't know. We at this stage we don't have a map, and it's an idea. But the flat earthers who are saying this is the map, they need to stop doing that, because that is then now opening it up to ridicule. And this is what we want to stop. We don't want to stop the ridicule, stop them trying to treat us as though we were a joke. Okay, And the way to do that, if we put ammunition in their hands, and say, look, this is our model, this is the AE map, immediately they're going to start pointing to stuff on it which doesn't work. For instance, flight across the Pacific. That doesn't work. The sun doesn't work. There's a whole bunch of stuff that's wrong if you choose the AE map. So what I'm saying is, I'm not saying don't look at it as a concept. I'm just saying don't commit yourself to saying this AE map is the Earth, because as sure as hell they will point out huge amounts of flaws with it.
So you have an opening paragraph or something that you wanted to state, because you had a few of these lined up, I'm sure.
Okay, well, look, no. Well, what I did was, I'll read.
Or did you just or did you paraphrase it? Sorry,
No, I'm paraphrasing my paragraph. Yeah, I am. So that was the first thing that I wanted to do. The second thing I'm saying to.
So let's clear that up then. So from a flat earther's perspective, this is just a projection to give a different concept to a public. So whereas the globe earther provides a globe to the public and says, this is where we live, this is the size of Greenland, which isn't the size of Greenland, by the way. It's like 13 times too big. But this is our model that isn't correct, doesn't work, doesn't look anything like the sizes or anything, and we just do the same as flat earthers. But again, like you say, I mean, we don't have the technology to actually find out for sure. I mean, we haven't got the ability to go up to 150,000 feet and travel around and see what's underneath, and document it. We don't have that technology. But
right, well, I mean, you can buy it. I mean, if you get together, you can easily do that. However, but anyway, we are on the same page. We're on the same page in that we both agree that we're not going to use the AE map as a committed model for flat Earth. We're saying that it's an idea. Have a look at this. This kind of an idea. We're not saying that it is, but it is an idea. So,
but it's still,
my point about losing the AE map as an absolute, that's a good point. So we both agree on that point. We're on the same page.
But just to finally to also clarify, it's not a million miles off either.
No. I'm not saying it is, and the globe people and Greenland's not a million miles off the reality either. So I don't think that's the point. I think the point is to say, well, yeah, okay, maybe it is close. Because let's say, for instance, I had this map in front of me, and I wanted to fix it, and I said, well, okay, well, the main thing is I need to fix things that are well known. If I have a look at the AE map and I look at Australia, that's totally wrong. That is 100% totally wrong. Australia is about as tall as it is wide. I've driven across both ways. I know how big Australia is. That map is wrong. So let's fix that. Let's have a look at some of the other continents which are totally wrong. Let's have a look at the Pacific. Close in, adjust the distances between South America and North America. It's wrong. It's just too far away.
So,
I mean, all of these things can be fixed. We can look at them and say, well, let's adjust these things so that they match reality.
Okay, so as a flat earther, how would you go about mapping the land? How would you go about doing that to produce some kind of map?
Oh, the obvious way is to fly it. That's the quickest way, is to fly. And to actually do some proper surveying.
And what sort of surveying tools would you use for that?
Well, like the standard stuff, theodolites, lasers, measuring equipment. That's modern measuring equipment.
But in
my day, we used to carry a chain around.
Don't you think that as flat earthers we have problems with the theodolites, obviously, with optics and the like?
I think you can. I think what you need to do is to verify your equipment. In other words, by measuring something with a known distance and verifying that your equipment either works or doesn't work. And if it doesn't, you've got to figure out you've got to get equipment that does. That's simple. A theodolite has got its limitations over very long distances, but in short distances it works. I mean, we do have cities. The cities are pretty accurate, you know, according to the town planning. Buildings are standing up, you know, so these things work, but maybe they don't work over great big distances.
Yeah,
I think the tools can be refined. Sure, there's no reason not to do it though.
But I think you've hit the nail on the head there. You can use the theodolite for 100 meters, for 200 meters perhaps on land, maybe up to 400 meters. You know, who knows? But when you go over water, you know, you start to see a little bit of an issue there.
Totally agree with that. So, and what I'm saying is that we need to survey. We need to do it a bit at a time.
So, do you not think that the land masses have already been surveyed? It's the water, the distances between and where they are located in relation to each other that's the problem. And theodolites aren't going to actually help that at all because they are not fit for purpose. Their tools just do not work when you're trying to visualize something over water.
Let's just say you've got a boat, Randy, that travels 10 knots, okay, or 10 miles per hour, and it takes you an hour to get over to the other side. It's pretty safe to say that it's 10 miles. That's not impossible stuff to do.
Well, it is if you're using a theodolite and you're trying to.
No, I mean just your time, just your watch. You know that your boat's going 10 miles per hour.
Yes.
It takes you 1 hour to get to the other side. So you know you've just travelled 10 miles.
Yes.
Yeah.
But have you travelled 10 miles? Are you not fighting the current? Are you with the current? Are you against the current? Are you against the wind? Are you with the wind?
Assuming that you know how fast the boat's going.
Yeah, so it's quite difficult to get precise and accurate. But then when you get to 10 miles, who's to say that you can see it with a theodolite down at sea level?
Yeah. Anyway, the other thing is.
Sorry, just one minute. I just need to shout out.
However you believe GPS works, it does work. The GPS does work. I need to go somewhere where I've never been before. It works. Sometimes it takes me on a bit of a wild goose chase to get there, but it always does get there. I've never put my destination in a GPS and it's not got me there. So the thing works. If I turn my phone on, I can tell you exactly what my position is, latitude and longitude. So these things work. The point is that we can use them. The thing is that we need to have the will to do it.
Well, hang on one second. Let me just shout out Godzilla for the super chat. Thanks very much for the $5 super chat. My next instalment towards the 500. Thank you very much. Much appreciated, by the way. But when you say GPS and things like this, you're assuming satellites now, obviously. But we're talking about optics here. You mentioned the theodolite, and I said that there's an issue with using a theodolite because you can't do that. And even at 10 miles, you wouldn't be able to get an accurate reading. Because in your model, well, not in your model,
agree.
as in the globe Earthers model, light bends in all kinds of directions. So whatever you're trying to see is always not going to be the reality of things. It's always going to be an apparent position.
Look, I'm not saying that. I'm not saying. Let's forget what we think. I'm not a baller anymore. I'm a flat earther today. Okay, so whatever they say, I don't care.
Okay. All right? So move on to your next.
I only care about what we say. I don't care about what they say. They can have their fantasy if they like. I don't care what they do. This is just about us. It's not about them.
I just want to say to Adam Meakin, I have seen your message, by the way. I did see that, and that was to point out Antonio Subirat's map. To be honest, it's not something that I've looked at, so I can't really say. But hey ho, just wanted to point
look,
out.
If he's got if Antonio Subirat's got a map that works for flat Earth, pull it out and let's get a whole bunch of us flat earthers together and to look at it and then evaluate it and see, does this work or not? And if it works, terrific, because that's what we need.
Do you want to see it?
Absolutely.
Okay, bear with me then. I'll bring it up.
While you're doing that, I'm just going to get a glass of water, okay?
Okay. Right, guys. As you know, this is completely out of my my depth. This is something that Professor Phil Bell wanted to actually get into today. So he's going to be an honorary flat earther this evening. Again, I don't know where this is going. Don't know what the plan is with it. I'm still kind of debating him somewhat on sort of being a globe earther here, but we'll see. We'll see what he's got planned. I'm sure he's got some tricks up his sleeve. Oh, and by the way, around about midnight or just after, I will be doing a Flat Earth Chit Chat show, so I'm going to be bringing in a few panellists. Let's get talking some proper Flat Earth stuff. So this is just what Professor Phil Bell wanted to do this evening, and, you know, I'm not going to oblige because I'm a nice guy at the end of the day, and I'm sure there's a trap waiting somewhere, but I'm prepared for it. You know what it's like.
Okay, I'm back.
Hey,
all right,
hey.
so this is Antonio's map, is it?
It is, yeah. It's the first time I've seen it.
I mean, it's pretty, but we still have problems with the Pacific. You can't accept the fact that that Australia is so far away from Africa or from South America. That's not right. That has to be a better adjustment to that. So I disagree with it. I disagree with it because, and by the way, Australia looks a hell of a lot better than it does on any of the others. So on that point, I agree. Africa looks terrific. Actually, South America looks exactly the way it does. The only thing I've got against this map is not the continents or anything like that. It's just the distance between Australia and South America, and the distance between those three continents in the south. I don't think are that far apart. In fact, in reality, aren't. So we need to relook at that. But it's a good way. It's a good start. It's at least he's put some pen to paper. So he's done more than most flat earthers have ever done.
Okay, right. So moving on. Oh, and by the way, thank you again to FE News for smashing the super chat yet again and saying cheers for having him on Ranty. So thank you very much. Right, you've got the next point. So you want to bring something else
my
up?
Next point is. All right, now this is going to be a really controversial one, all right? But let's try it out, okay? So I'm saying that admit that gravity is a thing. In other words, we drop things, they fall, we measure the rate of the fall, we can tell how fast it falls, and we know when we drop other things that everything falls at the same rate. So we can't deny that. The ballers can prove that we're wrong, which gives them grounds to ridicule and mock us. So denying these simple facts opens us up to ridicule. We can easily overcome this problem by describing the Earth as a plane. So in other words, it's flat, but it's cut out of an object that's at least as big as big enough to have gravity at 9.8 meters per second squared. So what I'm saying is that we don't know what the bottom's like. We don't know how thick it is. And what we're saying is that it's thick enough for the gravity to be 9.8 meters per second squared. So we can knock that one of their argument cold. It's gone. Doesn't mean that doesn't mean the top isn't flat. Okay,
so again, you're assuming that flat earthers are going to be beholden to mass attracting mass.
I mean, again, all right, so let me just stop you there for a second. This also knocks that argument. In other words, we're saying that, so what if mass attracts mass? So what? That's not an argument against the Earth being flat. We're saying, yeah, right, okay, things fall towards the Earth. The Cavendish experiment works. It's done over and over again. We can't argue that it doesn't work. So we're saying, all right, well, fair enough, but that doesn't prove that the Earth isn't flat. Okay, good. So what if the Cavendish experiments work? So what if gravity is 9.8 meters per second squared? So what if things fall at the same rate? We've got an explanation for that. The explanation is simple. The Earth is flat from our point of view, and it's big enough so that gravity works.
There you go. So, I mean, this idea that something's big enough so that gravity works, you're talking about mass attracting mass, but, essentially,
I don't see a problem with that. That's been proven.
Yeah, but is it mass attracting mass? I mean, as flat earthers, we look at the options, what's out there, what's the other options, is it mass attracting mass? Is it velocity that's creating something? Is there something there that's creating this? What is it? Is it electromagnetic? Is it the bending of space-time that's creating this gravitational force? I mean, this idea that we have a set idea as that it has to be a greater mass that's creating this 9.8 second per meter squared that's pulling stuff down. It's kind of neither here nor there, because we don't know. We see an object fall. Of course, we see an object fall, and we see a direction to the object falling. But if you look at what Globebusters Bob has put out recently, he's put out an explanation that covers both. Relative density, relative density equilibrium.
I'm not arguing with putting up other explanations. I'm trying to knock out their explanation. I'm trying to say to them, all right, so what if it's 9.8? 9.8 does not stop the Earth from being flat, because it could be, I'm not saying it is, I'm saying it could be big enough for that to be true. Or it could be some other reason, or it could be Globebusters' reason, or it could be, Jack and the Beanstalk's reason. I don't care. The point is, the ballers can't say that it's only this. They can't say that we don't have a flat Earth because of gravity. Because what we can say is we accept gravity. We accept that things fall. We accept that they fall at the same time. And what we're saying is that the Earth is flat at the top, but however big enough for this gravity to work.
Yeah, again, I have the issue, and I'm sure most flat earthers have this idea that the big scale, every time you say the word big, it attributes mass attracting mass, and I think
get used to it.
Yeah, because the idea. The word gravity sticks in the throat of flat earthers.
Yeah, and
right?
You know why it does? Let me interrupt you for a second. You know why gravity sticks in the throat? Is because that came from right at the beginning when Eric Dubé put that stuff together and didn't actually think this through. He could have knocked that on the head right there and then if he'd only thought about it for 5 seconds, but he didn't. And what's happened is that's now been adopted. So people are thinking, hang on a second. If we say that gravity exists, then we are denying that the Earth is we're denying that the Earth is flat. They're putting those two things together, and they don't belong together. The Earth is not. We can't say the Earth is not flat because of gravity. That's what I'm saying. That started at the beginning in this flat Earth thing, a few years ago. Well, it was wrong then. It's wrong now. Let's undo it. Let's get this from sticking in your throat. Gravity works. Gravity is there. You can measure it. Things fall at the same time. And we can explain why. It's because the mass of this planet, or this place where we're living, this plane, where the mass of this plane where we're living is enough for all of that to work. And by the way, because of that, it knocks a whole bunch of other stuff that they have out of the park.
Okay, so I've tried to sort of like steer you in a direction that says, hey ho, as flat earthers, we don't ascribe to this notion. And again, you've just gone over this again, but you're an honorary flat earther, so I understand this. I understand that you're trying to label and put things onto us, put words in our mouths about this gravitational force and this idea and stuff, but we're exploring that still. There's nothing concrete with anything that you've said. We're still looking into this, but I do need to shout out FE News because we want to discover the true nature of reality. Globies are wrong about the cause of up and down. Things go up and down, not just down. Thank you very much for the super chat. So do you want to move on to the next point? Because
Yep, sure. All right. Okay, the next one is is that one of well, it kind of leads on from this because some of the flat earthers, like Anthony, says that there's a contradiction between Einstein and Newton. Well, there's no contradiction, okay, in their model. So by saying that there is, all that does is put ammunition in their hands. Let's knock that out of the park.
Okay, so what
we're saying is we don't have to knock the scientists, all right? And that makes us look really, really stupid if we knock the scientists, okay? Those scientists, they are really, really brilliant people. We have got no business knocking them. So what I'm saying is that what we can do is we'll say, well, what have they got? How can we look at what they have and show them that what they have does not disprove what we're saying? So what I'm saying is there's no contradiction in their model. Objects bend space-time, not gravity. Gravity doesn't do the bending of the space-time. It's the object that does the bending of the space-time. Gravity is the distortion of the space-time. It can't happen without the object. Things fall into the distortion that's created by the object. That is why there's an attraction between the object. That's why for all the world it looks like things attract each other. There's no contradiction whatsoever. The equations show there's no contradictions. The idea shows there's no contradictions. We can accept that. Gravity is a thing. The reason that it's a thing is because our world, our flat world, is big enough, massive enough for gravity to work. Knock that stuff that they have out of the park.
Okay, so so there's no contradiction. What you're saying is there's no contradiction in the globe model between the two.
No, none at all.
Okay. See, I see it. Flat earthers would see it differently.
Well, they would, but they don't understand. I'm not saying they shouldn't understand. They not the way that they put spelling that out points to not understanding it. I'm telling you why. I'm giving you why it does. Okay, so why does it? I've studied both, obviously. Okay, I'm a physicist, so obviously I've studied both of them, and I can tell you there's no contradiction because as I said before, everyone thinks gravity that the objects that gravity's got something to do with creating the bending of space-time. It doesn't. Gravity doesn't bend the space-time. The object that's on it, that's in space-time, bends the space-time. So gravity's not that part. Gravity, if you like, is the well that's created because of the object that's in the space-time. And things that are in this well fall towards the object. And as they fall towards the object, it's the same as if you held it in your hand and dropped it. That's how it's falling towards the object in space-time.
Okay, so
there's absolutely no contradiction.
So as a flat earther, how would you address this? I mean, what would you say is the thing that flat earthers should do if this is the globe position and everything you say is correct about the globe? What should flat earthers do then to counter this?
The flat earthers don't need to counter it. That's my point. They don't need to counter it. All they need to say is, yep, you know why it works? It works because our flat world is massive, because it's so massive that it can cope with having this gravity. Therefore, we accept what you say. Fine, okay. Well, I mean, this again is a scientific model. There's nothing about truth in it.
I see where you're going here. So I didn't to start with, but what you're trying to say is that right, let me get this right. So what you're trying to say is that in your mind, if you was a flat earther, what you would be trying to say is that the land beneath our feet is probably, let's say, at least 50 times bigger than it is, and this is causing the gravitational effects that we see. Got it in one. That's right, it. I see. So you've come on the show to try and present a argument for what kind of reality may work, that if you take the globe arguments and try to destroy them to put them on a flat model, how it may work and how you can take their scientific proofs and turn it around and say, hey, if we have a flat plane that's 50 times larger and 50 times more mass than than the Mercator or whatever, then I see where you're going. I see where you're going. I can see your point.
We just knocked all of their arguments out of the park. But they can't say the Earth isn't flat because of this and this and this. We've just knocked all of that out of the park.
Okay, I can see where you're going with that. But ultimately, you're still saying that mass is going to attract mass, and
I'm saying let's get over it. It does. Let's get over it. They can't argue about it anymore. We're not saying it doesn't. We're saying that the Earth is flat, and yes, mass attracts mass. So what?
Okay, so what's your next point?
Okay, the next one. All right. Okay, this is a biggie. Okay, stop trying to deny the work of the greatest scientists that have ever walked on this plane. Okay, their work is tried, tested, and verified over and over by every wannabe Nobel Prize winner. Okay, every scientist out there wants to win a Nobel Prize. They would in 5 minutes knock anything like that on the head if they could, and don't think they haven't tried. So this idea that those scientists out there just put their fingers up in the air and dreamt up something, that's nonsense. This would have been knocked over many times over by the wannabes who want their own Nobel Prize. Okay, we can embrace these great scientists. Faraday gave us electricity. He also confirmed Newton's laws of motion. Was Faraday a fool just because some flat earth cult leader says so? Do you think just because Dubé says something about Faraday that makes it so? We can do better than that. We don't need to knock Faraday. Faraday is one of England's most renowned and revered scientists, just like Newton was. All of the best scientists came from that part of the world. You know, be proud of the scientists that you people have put together. It's because of them that we even have the technology and the stuff that we have now. It's because of those people, those English people, the people who belong to the Royal Society. That's where the brains of the world comes from. So what I'm saying is that let's embrace them. Let's not just knock these people just because they came up with some ideas. Yes, some of their ideas need refining. So what? That's how science works. It gets refined. So why are we parroting this thing about saying, you know, Einstein is a fool? The only person who looks like a fool is the person who says that Einstein is a fool, because everyone knows he was a genius. Okay, so why are the things needing? Let me have a read. Okay. All right. So we flat earthers, we keep banging on about the scientific method. But we flat earthers, we've never actually used the scientific method ourselves. When the hell are we going to ever use that? Let's just stop that nonsense. Let's just stop criticizing the scientists about that. Okay? So that's my main point here in point number 4. Okay, so here, every time a baller gives us a photograph, we call it CGI. But we give them photographs. We don't have to call their stuff CGI. We just have to find a counter argument against it. Again, just like I said, our world is a flat plane that's massive. They can't argue with that. The gravity works for it. We could even say that the photographs work for it. It's their interpretation of what that looks like. It's not our problem. It's their problem. They cannot argue that the Earth is not flat. All they can do is put their argument, and we can say, yes, so what? That's all we need to say. We don't have to go into this business of trying to jump through hoops, knocking famous people for nothing. That's just, it's just unnecessary.
From the Adam Meakin, okay, Ranty Flat Earth. Have your money now, make it stop, please. Wow, really, Adam? You're going to take Sleeping Warriors position on that? That's really brutal, mate. Well, thanks for the super chat anyway. Okay. Next point, please. So,
Okay,
bearing in mind. So, can I just say that is this from your perspective, right? So, because obviously you are a globe earther. So, have you sort of like listened to the flat Earth arguments and thought, and listened to other people talking about them, and decided to come in to try and say, okay, well, how would I broach this subject or this subject or this subject? You know, have you?
I have, and that's kind of what's led me to this. And I thought I was really thinking seriously about who I'd share this with. And I looked at around, and I thought, you know something, I wouldn't even share this with the Globe Channel. I didn't even want to share it with them. I wanted to share it with somebody like you. I thought this channel is fair income. That's an Aussie phrase meaning real. About looking for what the facts are, looking for the truth, if you like. Okay, so I thought, well, I'll share it with you, and you don't have to. The flat earthers don't have to accept what I say, but what they can do is they can reassess how they look at things and say, look, you know something, we don't have to accept the ridicule. We can actually answer their questions. We're putting an explanation that answers their questions. Science doesn't claim to have the truth. Science doesn't say that anything is the truth or that it's proved. They never do. All they're saying is, you know something, I've got an explanation with that, and until I find a better one, I'm going with it. What's the difference?
Okay, so from a flat earther's perspective, obviously you being an honorary flat earther right now, how do you feel when the globe earthers turn around and tell us that the science proves the globe?
I would say you don't know what the hell you're talking about.
I
said, no, it doesn't. Science doesn't prove anything. All you got evidence. You put these evidence together and you say, on the balance of probability, this is the most likely thing that's possible. So this is how science works. Science doesn't go around saying that this is the truth. Science and truth don't match. Truth is not a word found in science, and neither is proof. All it is science is saying that, hang on, I've got an explanation, my explanation works, and I'm going with it until someone else comes up with a better explanation. And when they do, everybody says hallelujah. They don't knock it. They don't get upset over it, over a new explanation. They accept it. They say, wow, that is a better explanation. Let's go with that one. That's how things move on. There's no reason for flat earthers not to have an explanation and say, you know what, we'll just go with this one while we working on it. This seems to explain stuff. We can say, yeah, you know something, that explanation for gravity works. You know why it works? Probably because our world is flat on the top and is very massive underneath. So that's why this gravity things works. Until we come up with something better than that, you know what? Let's go with it. Because those ballers, they can't argue with that.
Fair enough. I'll pass that one.
Okay,
but from a globe earth, put your globe hat on for a minute, and would you say the same thing about science? That science proves nothing?
Yes, absolutely. I most certainly would, and that's one of the things that makes me angry about when I not angry. Angry is not the word. It makes me concerned when I hear other globers saying stuff like, I've got proof, or this proves that, or this proves this. That's not how science works. So if they say that science has anything to do with proof, they don't know what they're talking about. It's nothing to do with proof. It's got to do with the evidence. How does this evidence explain what I see? Does it work? Does the evidence explain what I see? If it doesn't, I'll look for something else. If it does, that's fine. I accept it. However, I know in my mind I could be wrong. But this is working for me now. You know, like for instance, we use atomic theory to, we make factories that make aluminium out of bauxite. We're using the atomic theory to be able to do that. The ideas about what we understand about atoms and electrons, valencies, oxidation, reduction. We use all of that stuff to be able to make aluminium. To take aluminium out of bauxite and to make very, very accurate predictions. So we use that. Is it 100% right? our idea of why it does that? Is that 100% right? Maybe not. But I'll tell you what, this model that's been produced works. And until someone comes up with a better one, a better atomic theory, a better idea for why this does work, we're going with this one. And you can do, when I say you, I mean me as well, because I'm a flat earther today. We can do the same thing. This is what we do. We're saying, we accept that gravity works, and gravity works because our world is flat, but it's massive.
I'm just going to give a shout out to Pete Bremble for the £2 super chat, who says, can I have a FE map with a scale? I can't bring one up right now, but if there's anybody in the chat right now who wants to send him a link or put a link in the chat that may send him in a direction for one of them, that would be awesome. Thank you very much. So go ahead. You had another point.
Yeah. Okay. All right. So. All right, so the other thing is that, just to make a point on that, I'm saying that if we're going to debunk the globe model, us flat earthers, we have to at least understand what they're saying. Okay? For instance, they say there's no gas pressure next to a vacuum. Well, we keep saying that. We're saying, how come there's gas pressure next to a vacuum? They're not saying that. Why are we saying that they have to prove that there should be a barrier between gas pressure next to a vacuum when there's no such thing? They're not saying that there is gas pressure next to a vacuum. There's only one instant that could ever happen, and that's with a plasma. They're not saying that.
So what are they saying?
Why are we making this point? They just all they're going to do is laugh at us.
Okay, so hold on. So what are globers saying then?
Okay, so globers are what they're saying is that there's a gradient. They're saying that it starts at 14.7 psi, gets smaller, and just keeps getting like that. Just keeps getting smaller the higher you go. They're not saying that there's some point at which it's all of a sudden that it stops. It just gets smaller and smaller and smaller and keeps going like that. And the stuff that is there, because we agree that the gravity is there, the stuff that is there, gas has mass. You can actually weigh gas. If you put enough of it together, and you can drop it on your foot. How about carbon dioxide? 44 grams per mole. Make a kilogram of that into dry ice and drop it on your foot, and then come and tell me that gas doesn't have mass. Gas weighs stuff. Gas has mass. It weighs. It's a thing that will fall. Gas will fall if you drop it.
Okay. So at some point though, there is a vacuum of space. And
no. Why do you keep saying that?
At some point, there will be the vacuum.
No, there isn't. So there's always gas. There's just less of it.
So. At some point, the atmosphere of that extends now beyond the moon. At some point, it will end, or are you going to say that?
No, it never ends.
It never ends.
Never ends.
So there's always pressure somewhere.
Always. It comes down to how small it is. It never ends. So this business like that there should be some barrier is irrelevant, not necessary. We don't have to wear that.
So is that a? Sorry. Can I just ask? Hold on. Could I just ask though? Is that a globe Earth position?
I'm the physicist. I don't know any other physicists who come on the shows.
Oh, all right. Okay. So you're the globe. Let me just get this correct. So you're a physicist, and you're saying that in the vacuum, well, no vacuum space, there isn't a vacuum, there's always pressure.
If someone wants to argue with me, bring another physicist to argue with me.
Okay, I just want to clarify the position, because I'm a flat earther here trying to understand yours.
There's no place in the universe in which there's no pressure.
Right, shout out to Amanda Young for the $2 super chat. Ranty, please stop. No, I'm not going to stop. Professor Phil Bell's put a lot of effort into coming on, being an honorary flat earther right now. and he's presenting some things, and it's interesting to talk about. I'm going to be doing a show later, so there's no problem. We'll have a flat Earth chit chat then. But for right now, just keep it as it is.
Yeah. So, anyway, I'm just saying. So forget the dome. We don't need it. Okay. We don't need the dome. It doesn't matter. We don't need this in the way for them to ridicule us. There can't be a dome. There's a sun inside the dome. If we have to agree that there's a sun inside the dome, why doesn't it just keep heating up everything? We don't have to get that. Where do the comets hide for 76 years? All of a sudden, every 76 years, some comet comes out of nowhere from underneath the dome and flies across the sky. Why do we have to accept that? Why do we have to take this ridicule all the time? Forget the ridicule. There's no dome. We don't need it. Drop that dome idea. We don't need it.
Shout out to Awaken Narrative again. What Amanda Young said, he has no citations, and JQ says, let him go on. I'm enjoying this self-hanging. So thank you very much for the two super chats there. But yeah, I appreciate exactly what you said there. That if you have this this notion that there is no pressure gradient. Well, there's a pressure gradient, but there's no barrier between.
Yeah, there's no barrier, and there is a pressure gradient. That's the point.
Yeah,
that's why there's no need for a dome.
Yeah,
that's why we don't need a barrier, because there's a pressure gradient, and because we accept that we live on this plane that's massive enough for gravity. That means that sufficient enough of those gas molecules that have weight will want to tend to fall towards the ground, just like everything else falls. They know different. Okay, I can just skip past the atmosphere of the gradient bit. I did a bit on that atmosphere gradient, but obviously I don't have to explain that, because everyone knows that from the bottom of a mountain to the top of a mountain, you don't have a barrier. And yet the pressure is different. So you can see you don't need a barrier between pressures that are different. And how can we test this? Well, there is a formula that we use in chemistry. PV equals nRT. Tried and proven. Over and over again. Tried and verified. Every single time it works. It's undeniable. It works. Okay. We're flat earthers. We can accept that it works. No problems. We're not arguing with it. We don't want to argue with it. Let's throw that one out of the ballpark. Let's stop the ball earthers from ridiculing us over something like that. We don't need it. We don't need the dome. It's unnecessary. And not having the dome does not prove that the earth is not flat. That is our goal. Remember that.
Okay.
Keep your eye on the ball.
But that's only
keep your eye on the flat.
But that's only because apparently we have no vacuum of space, because there's always pressure.
Yep, always pressure.
Okay, so Pete Bremble, I just want to go back to your super chat and just say that there was somebody who, he's got rid of it now. Oh, yeah, there we go. Flat Earth Data says the Book of the Sun has a map, so that was in answer to your question. And also we had another super chat from FE News who says, has he been to space? So can I ask you, Professor Phil, have you actually been to space?
No, of course not.
Okie dokie, awesome. Right, so let's carry on.
Don't need to go to space. Can they have instruments?
Another one from JQ. Okay. Is the universe that you're imagining in your head contained, Phil? Is that how you're coming up with the pressure in space?
No, we know what the pressure is in space because we can measure it. We don't have to guess any of this stuff. We're not guessing it. We don't need to guess it. What for? We can measure it. Okay, so next one. No R value. Just drop that. We have an R value. We've got a big, massive Earth that our flat plane is on top of. Okay, there is an R value. Just because we don't know what it is doesn't mean that we're saying that there isn't. The ballers have their idea about what the R value is, but don't go and say that it's not there. It just makes us look dumb, and they just laugh at us.
So okay? Hang on, just one thing. So the R value, that's the radius value, yeah?
Yes, the radius, yeah.
So why would we need a radius value?
Because the reason we don't actually have to know what the radius is. It would be nice to know, but we can calculate it from the gravity. Okay, we can calculate what the radius is based on the gravity. So we pretty much know, we can pretty much work out what the radius is, and that's fine. That suits us fine. We don't have to argue with it.
But doesn't a radius give you a...
We don't need the argument. We don't need them to come back and say, oh, well, your Earth's not flat because of this.
But what shape does the radius give?
As long as the center of mass is the thing is large enough so that its center of mass makes it possible for gravity to be 9.8 meters per second squared, that's all we care about.
I've got a couple of super chats I just need to shout out. So from James Richards, is a negative pressure still pressure? Doesn't the spaceship
leave...
No
such thing as negative pressure.
Doesn't the spaceship leave the air, gas into negative pressure?
No. No such thing as negative pressure.
From JQ, what's the pressure is space pressing on, Phil? So it should be...
Pressure just comes from gas molecules that are in space. They have energy. They bang into each other. They bang into other things. They create pressure.
Okay, so again, going back to the radius, though, I mean, would the radius give you a shape, or I mean, does it have to be a shape? If you're saying that flat earthers would need a radius,
I'm saying that I'm saying if me as a flat earther, I would be going with a sphere for the rest of the plane, the rest of the world. I would be saying that it's probably a sphere. And as a result of that, I'd knock another bunch of arguments out of the ballpark.
Sorry, I just had to laugh there, Phil. Sorry. It's just when you said that as flat earthers we would go with a sphere. That's completely contradictory. Maybe.
No. The top of it's flat. I'm not saying the top of it's not flat. I'm just saying the rest of it is sphere.
All right. This is like what's happening now is you're going from your flat earther to your globe earther, and you're getting these mixed up.
Underneath it, you don't know how big it is. Even you don't know how big it is. Do you know how big it is?
Not at all. No. I mean, we can't.
You can't say I don't know how big it is, but it's not this.
JQ says, please let him keep talking all night. Thank you very much for the super chat there, JQ. Right, so next point, please.
Okay, next point. Okay, all right. Let me see. I'm knocking a few things out because I want to be kind anyway, and I don't want to. I'm actually a genuine flat earther, so I don't want to.
Okay.
Okay. So, all right. Looming. Yeah, that's my next point. Yes, looming is a thing. Refraction is a thing. You can't argue with that. Snell's law is one of the most tried and tested of all the laws of physics. All right. We're not going to knock it. We know that refraction happens. We know it happens in the atmosphere. We know it happens in water. We know if you're some kind of lousy fisherman and you try to spear a fish and you think it's where you see it, you know you're going to miss the fish. Okay, that's because of refraction. We know this. That same thing happens in the atmosphere. Atmospheric moisture can range from around 15% to 100% atmospheric pressure, moisture. And all along there is a gradient. In other words, a refraction will happen. Looming happens whether you're on a flat plane, whether you're on a curved surface, it doesn't matter. Looming happens. Okay, let's just accept the fact that looming happens. Just because looming happens doesn't prove it's flat. Okay. And I also have an answer for why the boats go over the.
Okay, let's just address this looming first thing first. So from James, well, first of all, James Richards says, "Can I join? I'd like to ask him some questions." I assume you've got probably another 20 minutes left, I would think. So maybe. And James is all right. He'll speak to you nicely. So
that's fair.
Okay, but with the idea with looming, I mean, looming has to be loomed up from beyond the horizon, behind a physical edge. That's what the terminology for looming.
Say, yes.
Yeah, but we don't need it.
That's what the ballers will say.
Yeah, but we don't.
It happens on a flat surface, and it happens on a. It would happen equally on both surfaces.
So is that from the globe? Putting your globe head on, would you say that that's the case too?
Absolutely.
Interesting, because that's something that I put to Joanism a few weeks ago.
No, it would happen on both. It would happen on both just the same. Okay, so it's that's a non-argument, right?
So can we conclusively knock out of the park any idea of optics for
yes,
looming
what we can
up?
knock out of the park is anything that says that the Earth is not flat because of looming. Because looming happens whether it's flat or not.
Yeah, but again, I have the issue with the refraction, yes, but the idea with the looming argument, it has to be brought up behind something else.
Yeah, so, it does, because the reason is because, you see, light doesn't go from your eye to the object. Light goes from the object to your eye.
Okay? Yeah, but can I just say, though, that this is where the black swan argument, as much as, I'm having a bit of a disagreement right now with the FE debate side, but their argument for the black swan, which they have hammered relentlessly for the past month or so, has definitely been a nail in the globe Earth coffin, because...
No, it hasn't, because of the looming.
Yeah,
it hasn't. That's why they can laugh at us.
Well,
because it doesn't. It doesn't. It does nothing.
It does for this particular reason, which is that
why?
Because the geometric horizon is in front of the platforms. But on the idea that looming, then it would always be in front of the platforms. It would never be behind it, the horizon. And that's the point. You can't have the platforms in front of the horizon, because that would never happen with looming. And,
with looming it would. With the whole idea about looming is things that are further away. In other words, further down over the ball. I'm talking about from a baller's perspective now. Okay, remember I'm a flat earther.
Okay.
So from a baller's perspective, things that have gone over the ball, the light shining on those things, the looming causes those things to come up. And that light, you actually seeing, the light comes from that object to your eye. It's not light going from your eye to the object. It's light coming from the object to your eye. And what happens is that the refraction causes those things to shift upwards. So it looks as though they're up there, but they're not. You're still looking down over the ball, but it looks like they're up there. So it's an illusion.
Okay, so...
Just like the fish in the water's an illusion.
I had a point to make and I've completely forgotten it. Should we move on? Because I'll come back to it at some point, I'm sure.
Okay. All right. Yeah. Okay. Let's just move on a bit. Let me go to another page.
Oh, sorry. Okay, sorry. That was it.
Chips going over the horizon.
What about sinking? Sorry, that's what I meant to ask. So. You're talking about looming, so is sinking real?
Okay, that's a good point. So what we're saying is, so when the ballers decided to debunk the black swan thing, the first thing they showed us was one of the pictures where you could see that the platform is actually behind, half of the platform's missing, and in fact. Look at any picture like that, and you'll see half the ship's missing. All right, don't say this is refraction. We both know that's wrong. We both know that's bullshit. It's not refraction. Okay, there is something causing half the ship to be missing. There is something causing half the platform to be missing. But the hell, don't tell me that it's because it's compressing the stuff at the bottom. Why doesn't it compress the stuff at the top? Why is it only compressing the stuff at the bottom? That's just nonsense. I'll tell you why the ships go supposedly go over the horizon. It's because we have tides.
Not just tides, but swell and shoaling effects.
Yeah, exactly. So stop saying water's flat.
Well done. Yeah, I would agree. I would agree with that. And would you agree with that as putting your globe head on?
Yeah, if I put my globe head on, I'm saying that water's not flat. If I put my globe head on, I'm saying that obviously it's a sphere. So all right, that's my globe head. But I'm not globey now. I'm a flatty, right?
Okay, so
from my flat Earth point of view, I'm telling you, there's an answer for it.
Okay, so put your Professor Phil Bell head on and say, would you agree that the shoaling effects, the tide movements, swell, all kinds of rips are going to have an effect on optics.
Okay, so from my professor's head, of course they'll have some effect of it, but they won't explain why you can always see half of the things missing. Let's say, for instance, there's no, if you're looking at, say, a turbine, and unless the refractive index is really high that day, the turbine always looks as though it's sinking. You know, you have to explain that under all conditions.
So what about magnification?
From a low tide point of view, I would say that maybe the tide's got something to do with it. From a high tide from view, I'm going to have a bit more difficulty with that. But I'm not saying that that's not the case. So from a flat Earth point of view, that's just a work in progress.
Okay, I just want to do a few super chats. So Awake a Narrative, ask pseudoscientist how much is helium nowadays. No idea what that means. But SX0, looking down the ball, he said, LOL. And Darwin says, Mason B is ace. Thank you very much all for your super chats. But I forgot what we were talking about then. So do you not think that magnification is a real thing that happens in the very small areas, the very small angles that you're looking at towards the horizon? We know that it happens. Yes. We know it happens with sunrises and sunsets and the moon rising and the moon sets.
Absolutely. You have a look at the sun. Sometimes it's huge, sometimes it's small. You know, that's all got to do with. I mean, I've got a light box over here. I was going to do some experiments with it. I've got a couple of very, very powerful lasers that astronomical lasers, and I've also got a light box. I can do some demonstrations with those things, and I will with that stuff. But yeah, no, I'm just saying that this is a bit of a work in progress for flat. I'm not saying that I've got all the answers. I'm just saying that it's about time. It's one of my points here about flat earthers being lazy. We're lazy, all right? We just shout at the world, and we don't actually do anything.
To be honest, I'm not lazy, but I want to shout out Frank, an LBB store, who says that atmospheric lensing, that was the word I was trying to look for. So atmospheric lensing, obviously we're talking about the magnification at the horizon. So that was the words I was looking for. So yeah, atmospheric lensing. Do you not think that is an actual effect?
Of course, it's got some effect, naturally.
Cool. So Mason B says, can we talk about COVID? Darwin is ace. Thank you very much for the super chat.
Yeah, we're getting to that. Don't worry. Okay, so somebody over there, Awaken something or other, reckons that I'm scared of a helium thing. I don't know why I would be worried about the price of helium. I've no idea. We don't use helium in rockets, if that's what he was alluding to.
Okay, your next point. And by the way, I think a lot of people in the chat.
Right, I've said what we have to do for homework. We have to stop being lazy. We have to start doing something. We have to start putting this model together. We have to start explaining how night and day works and seasons at the same time. We can't just ignore it.
Brian's Logic's done lots of presentations on that. Shout out to JQ, says, how many nights can we have Phil on? He has a whole lot of super chats for this, Ranty. There you go. Clearly, JQ loves your presence.
I was hoping that it would be good for you.
Thanks very much. But yeah, a lot of people aren't too pleased with you saying that we're lazy.
Okay, so all right. Let me just carry on so I can get to the end of this. All right.
Okay.
So I've explained why I think space exists. So let's knock that one out. We're not going to say space doesn't exist. Space exists. It doesn't need to be. We don't need to say it doesn't. Okay, satellites are real. We don't need to say that they're not real. Okay, we can knock that one out the park. Okay, this is really important. Both models are possible. Okay, yes, their model works. I'm talking about boilers. The physics works. It does not make it truth. So, flat earthers like us have a legitimate reason to expect that the truth is we live on a plane. So we can have both. All we're saying is that the ballers, they've got their reasons for believing in Earth. We have our reasons for believing that we live on a plane. All it is, neither of us are looking at this and saying, well, this is the truth. What we're saying is, this is what we reckon is happening, and until someone comes up with a better idea, that's what we're going with. That's how science works. Okay, so my point is, we've got lots of work to do. So let's get serious. Let's stop proselytizing, and let's get down to business and do some work.
Shout out to Godzilla again for smashing the super chat.
Big Bang now.
Hold on, Phil. So from Godzilla, here's another super chat for Ranty, and he's done another one who says, your guest tonight is a comedian, right? Question mark, question mark, question mark. Phil, are you a comedian this evening?
No. I wish I was. It's hard work. It's hard work doing what I do. Or maybe it's a hard work being a comedian too. I don't know. All right. So, Big Bang. Just accept it. Okay? From the ball earthers' point of view, it's what they did was have an hypothesis. How does all this happen? And Big Bang is one of the explanations. All right? You can't deny an idea. You can't say, oh, well, the Big Bang didn't happen. You know why? Because I don't know. If you're going to deny something outright, have your own reason for why it's not right. So don't say to the ballers, oh, Big Bang didn't happen. How do you know? They say to us, how do you know that it didn't happen? What do you know that I don't know?
How do globe earthers know it happened?
Okay, so I'm just telling you now. So what the globe earthers are saying that the Big Bang happened, that it came from a singularity. In other words, energy. It's the energy that got converted to mass. That's how things are there. They're not saying that things started from nothing. And this is what the flat earth people, us, we say to them, how does anything start from nothing? They're not saying that anything started from nothing. We made that up. We need to stop making up stuff, otherwise they'll keep laughing at us.
From SX0, who says,
my other point
just accepted, period, LOL. That's from SX0. Thank you for the super chat. Is this your last one, Phil?
Almost there, all right?
Yeah.
My last point is, I just want to address the religious people. All right? Okay, so what I'm saying is, if you believe in God, then stop mocking God. All right, this is what the flat earth cults are doing. The ones that have built themselves into a kind of a cult. All right, that's not you, Ranty. Okay, all right, those ones that are like that. In other words, no matter what you show them, no matter what you give them, they're never going to change their mind. They've locked themselves into this cult. All right, so if you believe in God, then stop mocking God. Look around you. Look at the elegance of the creation, the precision that's around you, the precision about how physics works, okay? And don't replace it with nothing. Don't replace it with some abomination that doesn't actually work, that's got no hope of working. I'm giving you some options that work, all right? You don't have to say to say that it's got to be in a dome, it's got to be this, it's got to be that. It doesn't. None of that's needed. So if you believe in God, then God's made this stuff perfect. He's capable of doing this kind of stuff. Doesn't need all of this rigmarole that you're adding around it. Don't say that evolution didn't happen. Okay? Why wouldn't God do that? If I was God, that's exactly what I would have done to make sure that the species continue to grow, that they continue to thrive, they continue to survive. That I would do exactly what happens with evolution. Evolution is the perfect solution for how to maintain life on this earth. Okay, so things didn't just get made. The evolution explains it perfectly, and if you were any kind of smart God, that's exactly what you would do.
Okay,
right.
So
almost there. Okay.
I just want to say I disagree with that, but you know.
All right, I can throw in just a few things. So here's some things, just a few theories, if you like, or well, not theories, hypotheses. Okay. All right. So How do we know that God doesn't have a multi-universe out there? How do we know that that's not the? How do we know that heaven and hell aren't hidden in some sort of multi-universe? If you believe in God, how do you know all that doesn't exist? Okay, so maybe there is multi-universes. Maybe the space is right and all those things are right, and out there's some multi-universes which we've got no access to. And maybe when you die, that's your portal, that's your Stargate into the multi-universe. Maybe that's the way to get in there. How do we know not? Okay, just keep your mind open. All right, and let me tell you this one last thing. Ballers are not going to change. No matter what you do, they're not going to change. And that doesn't matter. Atheists are not going to go away. All right? But that doesn't mean God that does not exist. This is not about making ballers go away. This is about flat Earth becoming legitimate and not just a baller joke. String theories out there is out of the box, but it's still regarded as legitimate theoretical physics. So is multiverses. Okay, these are legitimate theoretical physics. Flat Earth can also become legitimate if we just pull our fingers out and did some work. Okay, and what did I write for the last thing? I just wrote, okay. All right, stop blocking. Arwen's got me blocked now. Stop blocking people who disagree with you. If you listen to people who disagree with you, you'll actually learn more. Even if you disagree with them, you'll actually learn what they think. If you want to know what other people think, let them talk. But if you block them from talking to you, how the hell are you going to know what they think? How else are you going to formulate ideas and arguments if you don't know what they think? This is half the problem with the flat Earth, with us flat earthers. We don't listen to what the ballers say. So we make up our own idea about what they mean. And usually they just laugh at us. So embrace other points of view so that you can test it, so that you can check, see where it's wrong, see where it's right. Embrace the things that work. Throw out the things that don't work. Okay, and one last thing. Stop being disrespectful. Ad hominem does not damage the victim. It damages the perpetrator. So all those people who's probably giving me heaps of ad hom in the chat, stop it. It's not damaging me. The smart people out there, the people, intelligent people, know that I'm not a fool, okay? So you calling me that is not going to change anything. I didn't get where I am by being a fool. People pay me good money for what I do. All right? So stop being disrespectful. One last word, two last words. Stay flat.
Okay. I just want to shout out Pete Bramble for the £2 super chat who says, Conspiracy Cats is the new god. All bow down. Thank you very much for the super chat. But yeah, I'd like to bring in a guest, if that's okay, because I believe that James Richard wanted to join. Would you be interested in having a quick chat with him?
All right, as long as James is respectful, it's fine.
I'm sure it will be. I don't see why it wouldn't be. Let's see if we can bring him in. James Richard, so there we go. Let's add you to the call. And I hope he picks up, because I actually need the toilet. I might get an opportunity to run. Oh, and Cleary, feed Phil a Snickers. He is being a diva. Thank you for the for the $2 super chat there. Awesome, nice one, Cleary. Oh, and if you've got an opportunity,
I mean, that's kind of funny. That deserves a laugh. Okay.
Subscribe to Cleary. He's ace.
I'm probably going to have a lot of fun reading this later.
James, are you there, mate?
Yeah, can you hear me?
Yeah,
Yes.
we can hear you.
What's your name?
James.
Oh, James. Nice to meet you, James.
Yeah, what's your name?
Phil.
Nice to meet you, Phil. No, I just had a question of you earlier about the pressure in space.
Yeah.
So they'll tell you that it's negligible.
Yeah. It's not nothing. Yeah.
Yeah, like, so negligible, would that be equivalent to saying it's like there is none?
No.
Negligible.
It's not equivalent to that at all.
Okay.
There's all sorts of connotations about something when you say there's none. Okay, that would there's a whole lot of issues with it being none. Right? None means nothing. No, zero, zip. Okay?
So negligible is a false equivalent. Negligible is a false equivalent to none.
No, there's no none. There's always something out there, and all it is from any planet's point of view. I'm talking as a baller now, all right? Or actually, even from a flat earther's point of view, from any object that did have gas around it, that goes from something to nothing, it makes no difference. It is just a gradient. A barrier is completely unnecessary.
Well, it kind of is, because, I mean, if you had I think it's 1.22, it says negative in the power 11 to the negative 11th power.
Well, that's not negative. You know what that means? That means a lot of zeros.
I got you. I know what you're saying. Like a lot.
Yeah, 17 to be exact. If you're talking about pounds per square inch, 17.
Before you even get a reading.
Yeah, it doesn't matter. The difference between that and 14 is practically nothing.
Sorry.
What makes you think? Sorry.
Let me finish.
Yeah,
finish, sure. And you'll understand. So if you had that, all those zeros, and then finally a reading after the 17th zero in your tire,
yeah,
when you sat on it, would it go flat?
Of course.
Okay, so if you had 14.7 in your tire and you had the space reading, the 17 zeros before you get a reading on the outside, and you punctured the tire, what happens?
Well, nothing. If your tire only had 14.7 pounds per square inch inside it, it would be that atmospheric pressure. Nothing would happen. And a small amount like 10 to the minus 17 wouldn't make a difference.
That's what I'm getting at. The atmospheric pressure to the almost or by term negligible pressure in space. That's what I'm getting at.
Okay, there's very little difference. 14.7 pounds per square inch is bugger all.
I'm using the tire as the atmosphere.
Yeah.
And then space without the tire. That's what I'm doing.
Yeah, I don't think your analogy kind of works. I think it's a false equivalence. I wouldn't even take it there.
Isn't that what we would see? Like if we built a vacuum or an aquarium with the 17 zeros before you get a reading, right? And then on the other side of the aquarium, there's a barrier between. You had the 14.7.
Yeah.
And then you remove the barrier. What happens?
Well, obviously, though, the pressure would equalize.
But it doesn't do that in space. That's my question. Why?
Yeah, but which part of that? It's a gradient, didn't you get? It starts at 14.7 and gets smaller and smaller and smaller and smaller until there's nothing. There isn't a point where it's 14.7 and then nothing. There's no point like that.
Wouldn't the gradient come
exists.
After you already had pressure?
Sorry?
You couldn't get a pressure gradient without first having pressure, right? Wouldn't a pressure gradient be a delta to pressure?
No, the pressure gradient is a result of the mass of the gases. The mass of the gases weighing down.
You must already have pressure to get a gradient.
At the surface, it's 14.7.
For instance, if I have an air compressor, right, it's pretty much all the same pressure inside the compressor.
Yes.
But if I put a lighter started heating up the bottom of it, right? Wouldn't there become a gradient inside the container?
Yeah, you'd heat it up. If you started heating it up inside the container, you'd cause more pressure.
Right.
Yes.
Yeah. Well, we do have something that comes over us and heats us up, right?
That's you're actually debunking the dome, but yes, yeah, exactly.
Oh no, it'd be the same thing. In order to do it, I must have the compressor, the container.
Yeah. Look,
what I'm saying is you have to have the pressure before you can have the pressure gradient.
Yeah, well, of course, thankfully there are a lot of things on the planet that create the gases, especially the trees that create the gas that we breathe, the oxygen. Thankfully, they do, and thankfully, there's enough mass in the oxygen for it to stay close to the Earth so that we can breathe it.
So you're saying that, like, when you go in your bathroom and you look at the scale and it shows 0, right? You're saying that it's weighing the gas?
Yeah.
Or is it because if you put the scale in a vacuum somehow where you was able to calibrate it to 0, then pulled it out, then it would read somewhere around 14 to 15 pounds?
Let me give you an idea. Carbon dioxide would be 44 grams per mole. So it would take 22, just at normal temperature, it would take 24.5 liters of carbon dioxide to weigh 44 grams. It would take 24.5 liters to weigh 44 grams. So you think just a few, some small amount on the scale, you're going to notice it? You're going to have to concentrate 24.5 liters of the gas to equal to 44 grams.
Yeah, but that just makes me think that, like, gas is like water, right?
You've got that in one. It's called the fluid.
We got the most pressure, closest to the Earth at the bottom.
Yep.
That would be the bottom of the ocean in water.
Perfect.
Right?
You got it right.
But it would still have to be contained.
Well, that's why fluid dynamics works for gases as well as it does for liquids. Okay. The difference between a liquid and a gas is just the particles, the molecules are much further apart and more energetic.
So could it be the pressure that causes things to go down?
No, it's the mass. Pressure from where?
The air.
No, the air creates the pressure with molecules that bang around against each other, and also their mass.
Like water, right? At the surface, you don't sink as fast as if you're 500 feet down. Then you really start going. I
don't know about that. Why is that the case?
Because all the water pushing you down. The pressure.
You have to let me think about that. I don't know. Good question. Okay, so anyway, the point is, do you agree with me that if you're at the bottom of a mountain, you can breathe, and then when you go to the top, you can't? Do you agree with that?
Well, I've never been on a mountain. I've been.
Why do you think they carry oxygen to the top of a mountain?
Okay, I'll take your word.
I mean, why do you think they pressurize the cabin of an airplane?
Yeah, I've had my ears pop and stuff driving up a mountain.
You know why? That's because of the pressure change. That's why.
Yeah, but I played football and it didn't matter. It just seemed like I was playing where, 15,000 feet lower where I come from.
Yeah. This Mo Sampson says the pressure is statistical. Yes, it is. So it's not a linear change between the Earth and the further up you go, say to 60 miles, it's not linear. And yes, there is some statistical some statistics involved in how much there is at particular height. But in general, PV equals nRT works.
Right. I get what you're saying though. So go ahead, finish what you was getting at.
Yeah. No, I'm good. I'm just hoping that I can get some more questions from the thing, so I can help try and put this flat Earth model together.
There is. So could I just intersect and say shout out to JQ? So he says he did a super chat a long time ago saying every night, please, Ranty, he's doing his work for us. But his last one was a question. You have to have pressure before you can have a pressure gradient, Phil. Well, yes.
Yeah, of course you do. Yeah, the pressure is way down here on at the surface, though. Not all the way up there at 60 miles.
Yeah, but to have pressure, it must be contained.
Well, you know that you absolutely know for a fact that's not true because you have been to the bottom of a mountain and you breathed. And if you go to the top of that mountain, you can't breathe. So this is a fact that you absolutely.
That doesn't mean it's not contained, though.
Hold on. There's still pressure, right? No matter if you're at the top or the bottom.
Well, it is. It's much less. Now, imagine that you were at the top of the mountain, and then you went another 29,000 feet.
Hold on a second. That's what we're saying, right? There is a gradient. We agree.
Of course, there's a gradient. Yes.
Well, there must first be a pressure before you can have a gradient.
Yes, right down at the Earth. Well, why wouldn't there be?
In order to have gas pressure, even in the definition of gas pressure, it's the amount of molecules or pressure from the molecules.
Yeah, sure. I get what you're saying.
The container.
Not quite accurate, but I get what you're saying.
That's the whole argument. If you had a lower pressure next to it without a barrier, they would equilibrize. They wouldn't stay apart.
No, but that's not true. You know that that's not true. Why are you saying that when you know it's not true?
Demonstrate it. Demonstrate.
Get on the bottom of my mountain and climb up to the top and see if you can still breathe.
No. You're demonstrating gas pressure next to gas pressure.
But what if you just keep going on and on and on? I didn't say there was any place in anywhere in the universe where there's gas pressure next to no gas pressure, except in a fusion reaction. In a fusion reactor, that's different.
Yeah, I'm sure
you should actually pour a gas.
I'm sure that gas pressure in the atmosphere changes all the time, especially day and night.
Yeah,
when you have heat. No,
absolutely.
Right.
Absolutely right.
But to have pressure to begin with, you must first have a container.
No.
In order to have
pressure. But you know that you don't.
No, gas pressure.
I don't have to say anything. You know that you don't. You know that you can go from the bottom of the mountain to the top and the pressure will change. And if you go higher than that, it'll change even more. And it'll go all the way. When you're 60 miles away, there'll be practically none. We know this. We don't have to argue about it. We know what it is. All we got to do is find out the explanation for it. We don't have to argue the facts. We just have to argue about why.
Can I argue that fact?
Yep.
I'll argue the fact. So when you say pressure, what do you mean?
That means the gas molecules are weighing over on top of each other, as well as the energy that's causing the molecules to bash into each other. Bash into anything that's around it that's in its space. That's what I mean by pressure.
Okay. So do you see gas molecules, or when you say pressure, are you explaining an effect that you experience?
Of course it's an effect.
Okay, so that was it. You're explaining an effect, right?
Yes.
Okay, so gas molecules are not an actual thing. They are something.
You bet they are.
Wait, you're cutting me off. Be civil, Phil. So you can respond when I'm all done. So what you're trying to tell me is that when you say pressure, what you're actually referring to is an idea that you have about gas molecules to describe an effect you experience. Am I correct?
No.
What part am I incorrect again? Okay,
no.
What part am I incorrect about?
Okay. What you're incorrect is inferring that gas pressure is just an idea. You're totally incorrect.
No, hold on. I said the molecules bouncing around to cause the effect is the idea. The effect, breathing is real. Now, you're going to say breathing, you explain breathing with bouncing balls. Now, what I'm saying is breathing is real. It being hard to breathe at the top of a mountain is real. Now, your explanation for why is not real.
Why? What's my explanation that's not real? Where am I wrong, and how do you know I'm wrong?
Okay. So, no, hold on. Here's you're not hearing right. Wrong, right? No. What is real is what we experience in reality. Do you agree?
Yes, that's fine.
Okay, so is breathing something that I experience, or do I experience little bouncing balls entering into my nose and mouth?
Both.
Okay, where I never see these little balls, how do I know they're there?
Of course you don't. Of course you don't.
Okay, but then how do I know they're there?
Well, because we know this again. Switch your hands around in the air and see if you can feel any pressure.
Okay, that doesn't mean it's from little bouncing balls. You're telling me in effect. So this is my point. Will you admit that atoms and little bouncing balls, are you trying to explain why I feel resistance when I swing my hand?
They are factual.
Okay, so
yes,
if they're factual,
of course I'm using them to explain why you feel them.
Okay.
But I can tell you why that is the case.
If it's factual, why do I disagree? Why do I say no, atoms are not
Because you don't know enough about it. That's why you disagree.
Okay. So would you say that your explanation is personal belief or it's fact?
It's fact.
Okay, so what if I had another explanation for why I feel resistance when I swing my hand?
Well, apart from the fact that you ought to get a Nobel Prize for it, try me. Tell me what it is.
Okay, what if air is a fluid like water and it's not made of empty space, but it's uniform?
Air is a fluid like water.
Okay, no, but here's the thing.
I'm not arguing with that.
Okay, but you think water is bouncing balls again. What if water, what if there is no empty space in water because it's completely taken up with water?
Well, water doesn't compress very well, so to that extent, you're right.
Okay, but here's the thing. When you say compress, what you're doing is first assuming that water is made out of balls with empty space, that you can remove that empty space by closing them together.
If water's in the atmosphere, for instance, that would be a good example of where there's lots of space in between the water molecules, yes.
No, but here's the thing. Why do you keep asserting that the air is little bouncing balls when that has never been proven? That's just your explanation for why I have resistance when I swing my hand. When?
It has been proven.
When?
A simple third grade experiment will prove to you that it is.
Which one?
That it is what it is.
Which one? Let's do it, and then I'll believe in atoms.
So one of the easiest ones that probably most people who are listening to this will have done at school or even at home is put a candle in a bowl of water and then put a glass over the top of it. When the candle goes out, the water rises.
Okay,
why do you think that is?
Okay, here's the thing. Now you're going to ask me why. Would you agree right now that you have a story for why that happens, and you're asking me for my story?
Yeah. Now, there's more than that.
Answer that question.
No. Listen.
No, you're not listening.
I'll give you some more.
Hold on. We both have the observation, right? We both just seen the candle, the water, right? We both seen that. Now you're going to say, why did that happen? Right?
Yeah, that's right.
Now I can make up a story based on my personal beliefs, and you'll make up a story based on your personal beliefs, right?
Well, go ahead.
Okay, but do you agree that they're both stories?
No.
Okay, so you have the facts.
Corroborated in other ways.
Okay. So now we've left from what we've observed. Now, what we've observed, you don't even care about because you already have established elsewhere what is truth.
No, that's not how it works. That's not how science works. Okay?
No,
so
science.
What happens is I have an explanation. So science works like this. I form a hypothesis. I have an educated guess of why things work.
Okay, a guess.
Just let me finish, okay?
I know the scientific method.
No, we're doing it for the sake of the people out there, not just you and me, okay?
So you can't leave the candle. You can't leave the candle. Explain why the water rises and why.
How about let's go through it part by part, okay? So let's start with the first part.
Leave that alone. Go
ahead.
We'll
go part by part. Let's go part. What's the first part of the method?
Okay, so let me give you another example. So when we
let's talk
we
in the
have
method. I thought we were talking the method.
Listen.
Are we leaving the method?
Listen to this. I've got a better one than this. Okay. Listen to this. When we have two parts of hydrogen and one part.
Stop. I'm going to stop you right there because you've proven that. Hold on, wait, because
listen.
Before you
wanted to know why they.
No, but here, listen to me. Before you've proven that hydrogen exists, you're starting with hydrogen. So that's circular logic. So I have to stop you. So before you can tell me that hydrogen is real, I'm going to need you to prove that atoms are real.
Oh, okay. Well, we've got a long way to go, mate. Okay.
No.
Not on
You got
this
a
show.
long way to go. You got a long
Not
way
on
to
this
go.
show.
I never claimed atoms were real. You did. So you got a long way to go.
That's okay. If you don't
So you
believe
better
in
start
atomic
working.
theory, that's fine. I
Theory.
can't.
Theory
I can't
is an
help you.
idea. I agree that you have an idea which tries to explain observations. I'm trying to get you to admit that it's just an idea or an explanation. It's not
No,
the
it's
empirical
not.
facts.
It's backed in so many ways. Put it this way: if it's an idea, it's a bloody good one because it's backed up in so many ways.
It's a detailed idea. It's a detailed idea. Now, what it is you have observations and you've backward engineered. Hold on, listen. You've backward engineered the explanation. So you observe something, then you make an explanation. Then you observe something else,
normal.
and if there's any difference, you just change the explanation. So you're adapting your story. Hold on.
Yeah, well, of course you do. Of course.
Yeah.
You
look
it's
a story that you change.
Well,
so you agree that that science is an ever-changing story.
You bet.
Okay, well, that's garbage. I know another ever-changing story. I tell my little dog it before I go to bed to help him sleep. That doesn't mean it's real.
Well,
it just
let me
means
tell
it's a
you
story
something.
I've made up.
No.
Thank you for admitting that, Phil, though. That was a big...
The difference between your story and mine...
There is no difference. A story's a story, Phil.
No. Do you want to just be quiet just for a second till I explain it? The difference between your story and mine is I can use my story to predict exactly how much aluminium I'm going to get out of every ton of bauxite. Use yours now. Tell me how you do it. I can tell you how I can predict exactly. I can tell you. You give me so many tons of bauxite, I can predict exactly how much aluminium I'm going to get, exactly how much carbon I'm going to use.
I heard you the first.
You tell me how yours works.
I heard you. Okay. So now when you say predict, when a prediction is, let me finish. A prediction is a story that you're going to tell me. You're going to say, let's simplify it. I have a rock, and you're going to say, I predict that rock will fall. You're not predicting the rock will fall. You know it will fall because you've done it already. So it's not like you have a block of whatever mineral you named and you say, I know no, you've done it already. They've created a catalog of hold on, let me finish. I'm not done yet. Be cordial. They've created a catalog of effects, right? So they know when you do this, you know when effect X happen, you get effect Y. They know this, right? That's not a prediction. That's knowledge of observed events.
No.
Yes, it is.
You tell me I can tell you. All right. So, what are the chances
if I give you
any random number? Go on, give me any random number. Any random number between 1 and 100.
Math is language.
Oh, hold on now. When you say aluminum,
let me explain to you so I can explain it to the people out there. You give me any random number that comes into your head for the amount of grams of bauxite, and I'll tell you exactly how much aluminium.
You're not going to tell me. You're going to go on Google, and it will tell me because somebody's done it already.
I don't need to go on Google.
You memorized it then.
I'm a trained scientist. I don't need Google. What are you talking about? I can teach Google.
All you're going to tell me is something that you've done already, so you know the outcome. That's not a prediction. That's knowledge.
You give me a number, and I'll tell you.
You're not addressing what I just said. When you tell me what you're telling me, that's not a prediction. That's knowledge.
Yes, it is. I'll predict
it's not
how much.
You know it. You know it already.
And I'll predict for you.
Phil, when you know it already, it's not a prediction. It's knowledge.
I don't know. How will I know?
Listen.
I don't even know what number is in your head. How will I know?
You're not listening. Phil, you're not listening. If prediction would be, I predict the Bulls will win the Super Bowl, even though they're not playing in baseball. That's a prediction, okay? When you say, let me finish. Stop talking. Be cordial. When you say you can take X amount of this, that's knowledge.
No, rubbish.
Yes. Don't just say no.
No, you come up with
hold on,
and I'll predict how much bauxite.
Don't just go no.
How much aluminium you get.
Because you know it's knowledge.
No, nothing to do with it.
It's been done already.
But how do I know? I don't even know the number in your head.
It's been done already. Because somebody's been done
already.
Hold
on, let me say something.
So whether it's 10 grams or 100 grams, you'll know it because there's a formula that it will always be because you know it already. That's knowledge.
I wish I knew.
It doesn't matter.
Because there's an infinite.
When you have a formula, you plug numbers into. It doesn't matter what numbers you get. You'll always get an outcome.
How did I get this formula?
Because somebody out there took math and used it as a language to express what happens, because that's all math is. 1 plus 1 in numerical 1 is no different than O-N-E, P-L-U-S-O-N-E. It's the same fucking thing.
Well,
it's just, yes, it's a language. So what they did was they took, hold on, let me finish.
Theory. That's what that's what was used.
No,
it wasn't magic.
What was used, hold on. The observed effect was used. So you took gold and you did, observed effects. And you built a catalog of observed effects. That's it. You know a rock will fall because you've dropped it. You know, quote unquote, Jupiter.
I'm talking about turning bauxite into aluminium metal.
Everything. They've done everything already. They know how everything works.
I'm loath to put these guys on mute right now, but I really have to thank Aaron Moorfield for smashing the super chat here. It says, great show again, Ranty. Thank you very much. Thank you. Awesome super chat. But back to the show. Thank you.
When you do things in reality, it happens.
Do you understand that it doesn't matter? That it only matters that I can predict how much aluminium I'm going to get?
But you're not making predictions.
That's what matters?
But you're not making predictions. You have knowledge based on previous
events. It doesn't matter what you think. It only matters that I can make aluminium.
Let me just say something. Please, let me just say something. All right? So would you both agree that the table of elements is an empirical science?
Of course.
Disagree.
Like it's chemistry.
I disagree, because hydrogen, oxygen are not observed. You'll never observe hydrogen in nature. You observe a gas that they've told you behaves like something, which is a bouncing molecule of hydrogen. You'll never observe an atom in reality. An atom is an explanation for an effect. No, you did not have hydrogen. You had an effect. You had an effect.
Let me just. Well, that you could be true on that.
No, I am true. It is true.
Let me just
you never saw hydrogen in your. Bro, let me tell you. Stop talking. You've never seen a fucking hydrogen molecule in your life. Stop lying. Nobody fucking has. That is an explanation. Hydrogen is an explanation for what happens when you do electrolysis.
No.
I gotta say it again. You are explaining with words. Do you understand me? Do you get this? Do you agree?
Let me ask you something.
But no. Do you agree? Do you agree or disagree?
Just be quiet for a second.
But just agree or disagree. Do you agree that hydrogen is an explanation?
Have you ever seen gas burn at different colors?
Do you see the gas burn, or do you see a fire change color?
I'll agree with you on the molecule.
You're seeing an effect.
Let me finish.
No.
Let me finish. Yes.
Is hydrogen the explanation? So you don't witness hydrogen. Hydrogen is the explanation.
If you have different gases, right, and they burn at different colors, right? In order to put definition behind those colors or gases that burn at colors, you give it a name.
Wrong. What you're getting is different effects.
Just let me finish.
Hold on. No, let me finish.
I'll agree with you. I agree. But you're missing my point.
Let me finish. Different colors. The same gas can give you different colors based on impurities. So don't say there's different gases. You're giving into the assumption that there's different gases and not just one gas or fluid with impurities in it.
Or heat.
Heat is a concept.
Okay.
Exactly.
Heat is a concept. Show me heat. Right. Show me heat. If you can show me heat and not hot matter, I'll agree that heat is not a concept. Heat is a concept to describe hot matter. You guys are so fucking behind. This is because you're listening to Nathan Oakley every day. You guys are so behind. You think
the irony
is
force is real on that one.
The irony. Yeah, a force is a concept too.
Chris, another analogy for what Phil was saying about his predictions is, if you think about having the times tables, your 10 times tables. Now, he doesn't know what number I'm thinking of multiplying, but he's going to know the answer because it's been done. It's not a prediction. It's
beautiful.
Just, Yep.
Give me any two numbers. I can predict what their multiplication would be. No.
Exactly.
You know what it is. You've just memorized it. Nice. Thank you.
Yeah, exactly. Yeah.
So, Paige, you don't believe in atomic theory as well? You don't think water is H2O?
See how he says believe? Do you believe in God, Phil?
That's my
No, well, if I'll tell you if I believe in atoms, if you tell me if you believe in God.
No.
Well, then I don't believe that.
So you don't think? So you don't think? Paige, I'm talking to Paige. Paige, you don't think water is H2O?
I don't think matter is bumping particles. No.
You don't. You don't. So in other words, you don't think that atoms exist.
Not in the way you guys try to say they do.
What do you think? What do you think water is, Paige?
What do you mean? What do I think water is? It's wet.
Well, you've got water. What do you think? What do you think the smallest divisible particle of water would be?
See, this is where you're getting into what I think the world is actually made up of. And if you want to know that, then I would say that everything is light being vibrated frequency in different forms, and our consciousness affects it and turns it into whatever that thing needs to be. Like,
sorry, I didn't get that at all.
Very quick shout out here to Silent Zero for smashing the super chat. Get him right hand, indeed.
Okay. When they do the experiment with light, where the collapse of the wave function happens, I'm assuming you know about that, where they look, and depending on whether someone's looking at it,
Yep. You're talking about the double slit experiment. Yes, I know it quite well. We run it in my lab many times. Yeah.
Well, the way I look at that is that if your consciousness being there, knowing the fact that there is something there with a consciousness, knowing what's going on, changes what that matter decides to be. So the ether, your consciousness is always in contact with the ether. The ether is everywhere. So your consciousness affects the ether, which then affects the frequency and the vibration of the ether, which then, or of light, I'm not sure what it's the things are actually created from in the beginning, but that's what creates matter. And the more solid the matter, the more dense the vibration.
Can I ask
the lower? Yeah.
Can I ask a question, Paige? And
Sure.
It's not for you. It's for maybe other folks.
Can we just?
Hey,
can I just? Yeah. Can I just introduce you? So this is Aaron, guys. If you haven't come across him, so go ahead, Aaron. Oh, and thank you for the super chat as well. That was awesome. Thank you.
You betcha, man. You support what you love. That's what I do. So
Absolutely.
Where do atoms come from? And this is not a question.
I don't think they are atoms. I think
it's not a question for you, Paige. It was Paige. It was a question for someone else.
A really quick shout out to Good Servant for smashing the super chat. Thank you very much. You're always there with the super chat, so much appreciated, mate. Thank you.
At the time of the Big Bang, protons were, protons smashed together, create heavier elements, and so on. So I mean, that's how it originally happened.
Atoms.
I mean, that's one of the theories, anyway.
Well, why isn't my theory that God created everything the way it is? Why isn't that just as good a theory?
Paige, I have the guy that just spoke about where atoms come from. Can you say that? So atoms are the building block of life. Would you say that?
Well, the building block of all things that you see around you, of all matter, yes, pretty much.
Okay, cool. So my wife just got pregnant.
Yeah.
And so, are you saying that I shot a bunch of atoms at her?
Pretty much.
Okay, cool. Where did I get those atoms?
Well, you ate food, didn't you? You breathed oxygen, didn't you?
So atoms come from food, or?
Well, some of them, yes. I mean, why do you think you grow? You were a baby once, and now you're probably an adult. How do you think you got there?
I just asked you what an atom, where it comes from. You said the Big Bang, and now you're asking me how I eat.
No, because the atoms come from the food that you eat.
Where does the food that I eat come from?
I don't know. What do you like to eat?
Okay, sir. The atoms of the food that I eat, where does that come from?
From the food that you're eating, of course.
Oh, okay. All right, cool. Someone else take over this ridiculous.
I'm not sure what you're after. You grow because of matter that you consume.
The idea that you think the atoms that I shoot out of my dick into my wife and that makes a baby,
No, they're cells.
Comes from a Big Bang.
They're cells, and those cells are eventually made out of atoms.
Is
nitrogen,
they came up with atoms
oxygen,
because that was the smallest thing they could see at the time.
Exactly.
But the problem is we've gotten a little bit further along in
amino acids.
Sorry?
DNA, RNA.
One of the problems is
you don't know what these things are. Why are you saying these
Phil, would you agree?
Yeah.
Professor Phil, would you agree with me if somebody came up with a better explanation than atoms, right? One that was so good, flat earthers, ball earthers agreed. Would that be fact now?
Pretty much.
Well, do you not see how it's personal beliefs, not facts?
No, it's nothing that. I told you in the beginning when I started this, when I even started this, that's not how science works. This is the best explanation we have. We use it to make our predictions. And if you come up with a better one, we'll adopt it.
Okay, hold on. Who determines whether the explanation is better?
Exactly.
Personal belief, right?
You find a better way to make aluminium out of bauxite.
Hold on, Phil.
I'll use it.
Phil, listen. The explanation. Hold on, Phil. You don't use the explanation to make aluminium. You use aluminium to make aluminium. Okay, so the fact that you have an explanation. No, you don't use the explanation. The explanation is the story you've told for why what you just did.
I know. Listen, I know I have to put in the bauxite. I know I have to smelt it with so many grams of carbon.
Yes.
For it to be reduced to aluminium and oxidize the carbon to make carbon dioxide.
You're right. That's 100% correct. But the explanation came after all of that.
What about when a woman creates a baby?
To do it, I'll do it.
Professor Phil, what about when a woman creates a baby? Let's go to real shit, like life shit.
Yeah,
what if a woman creates a baby? So tell me how the atoms work, the ones that you're talking about that allow her to create a baby. Like, who does that?
Well, she's got cells in her body. She's got eggs.
Where'd they come from?
Well, she's born with them.
Okay. When she was born,
what he's asking is if you go back to the first.
I mean, that's just part of biology. And by the way, you're talking to a physicist, not a biologist. Okay.
Phil, if I found an error, or if I found a problem in atomic theory, would you admit it's wrong?
If you found a problem, yeah.
Yeah, if I found an impossibility, would you be like, okay, it can't be that?
Yep.
Okay, so now picture wood. You're telling me that wood and gold are both made out of electrons and protons, right? Just arranged differently. Just arranged. Okay.
Yep.
Can you show me anywhere in reality where you can take two fundamental building blocks and build different materials out of them?
What do you mean fundamental building blocks? You have to be more
lead to gold. Lead to gold.
Okay.
Yeah, I can make lead.
Okay, so when I say fundamental building blocks, okay, I mean something that can't be like if you had something that can't be reduced down anymore. Like you believe electrons and protons are the smallest unit, and when you rearrange them,
that's the smallest.
Photons don't have matter or mass, or the Higgs boson, they don't have any matter to them. So the smallest thing that has matter.
The protons
but do they have matter?
Further.
Okay, but to make up physical matter, the particle must have matter, right?
Mass.
Matter. Same thing.
Okay. So a proton.
Will you agree that mass and matter are interchangeable?
Yeah. Okay.
Okay, so we'll use matter. So in order to make up a physical, like something physical like gold, it has to be made of physical particles, right?
Yes.
Okay, so those physical particles have to be made of matter. Now, the smallest thing of matter in your world would be electron or proton, correct?
Well, let's just go with that. It's not, but we'll go with that.
Okay,
Yeah,
but for conversation's sake, okay. So now what you're saying is that you have these electrons and protons, but when you put them together, you get gold, wood, glass, water, gas. I don't understand that. That makes zero logical sense that you can create massively different fundamental materials with the exact same building blocks, just rearranged differently. I could take bricks and rearrange them. They'll never be wood.
Well, I'm telling you, for instance, the difference between hydrogen and helium is just another proton.
No, those are gases. Those are.
It doesn't matter.
But no, they're not different. They're not different.
The difference between gold and lead is 3 protons.
No, well, that means nothing to me. You're not showing me that. You're just explaining why you think gold and lead are different.
That's why you believe what you believe, because you don't understand it.
That's why you believe what you believe.
For you to know.
No, we understand what you're saying. We just don't agree with it.
For you to know that these atoms are rearranged.
Right the hand. If he says that the difference between lead and gold is only 3 protons, and we know what protons are, well then fuck. We can get some lead and make some gold. Because
he thinks that's possible. He thinks that's possible.
I'll tell you what, though, it'll cost you a lot more than just going and getting the gold.
I told you, he thinks that's possible.
Hold on, I'm on your side. If you know that these atoms or molecules are rearranged, then that means you must see how they're
You don't know
arranged.
what they are. That's what Right Hand is saying.
No, I agree. I agree with what you're saying. I'm talking to the other guy. In order to know that they're rearranged, you must first see them rearranged or arranged differently. Therefore, you know how they're arranged for gold, for wood, and you should be able to create it like these guys are saying. Because you know how they're arranged.
Exactly.
You can turn gold. You can remove 3 protons and out of lead and create gold if you had the facility to do that.
Yeah, and if I ask God hard enough, maybe he'll turn my lead into gold, right?
Well, look, you can be ignorant if you want, but I'm sorry.
You can have faith in your story. You have faith in your story, Phil. I'll have faith in mine. Okay.
Well, you know the thing about it, it's doable. You know that you can turn uranium into plutonium.
I know you believe it's doable. Have you ever done it though?
Well,
no,
I haven't
never done it.
Gold. That would be a very expensive process.
Yeah, I know. So you believe it can be done. This is something that you believe. It's not something that you know.
That's right. He's never done it.
No. I know.
Yes. So how do you know it?
I'm very, very confident of that.
You believe.
Yeah,
yes, and I'm very, very confident that God is real too. Yeah, I believe God is real.
I'll tell you what gives me the confidence. What gives me
your
the
personal beliefs.
No, what gives me the confidence about knowing what lead is that, for instance, I know exactly how a lead acid battery works. Okay? And I know that because I know what lead is. And I know all about its... I know that
I know
its configuration.
God created us because women give birth to babies every day. So I know we were created. Like, it's the same thing, Phil.
Well, you're allowed to think that you were created, surely, but I can tell you what.
Exactly, and that's what we're trying to explain to you, ballers.
I've never said you're not allowed to believe what you want.
He's just playing a ball.
I didn't stick a lead bar into my wife when I had a baby. Right?
Can I just change the subject just a tiny bit and ask, when you were pretending to be a flat earther and you said that we needed to stop asserting that there was a dome because the sun doesn't work.
Yep.
What did you mean by that?
Okay, what I meant was
why doesn't the sun work?
Okay. The reason is because if you have a dome that's enclosed in a system, and the sun is a continuous process of fusion, producing radiation, producing extraordinary amounts of heat. Underneath this dome that would obviously be heating up all this gas that's underneath this dome. It would fry everything after a while.
Okay, what if the sun is within the firmament?
Well, it's especially bad if it's within. Especially bad if it's within a dome.
No,
yes.
no.
What if there's like an opening that allows that recycles the air and cools it? Because the Bible talks about gates that flush the air. So you don't know what happens at the edge of the world. Look at the hoops you
have to jump through.
Hold on.
Look at the hoops
wait.
Jump through.
Yeah, you make all sorts. This is what an explanation is. An explanation. That's
air pressure with no container. Show us a gradient.
Yeah, he'll explain it. He'll explain it with gravity, just like I explained it.
If you didn't have the sun in the dome, you would still have a gradient. But because you've got the sun in the dome, you'd end up with convection. So you wouldn't have this gradient. It wouldn't exist.
No, because you're assuming you know what the sun is.
Of course I do. How would I not know what it is?
Have you ever been there?
I don't need to go there. I've got instruments. I've got a spectrometer. I've got one right here.
Yeah, okay, so you point this device.
You could look at Brenda and know she's
a tuning fork.
I've got a spectrometer. That's how I know what the sun is.
Long hair.
No.
Give him the point. Give him the point. Says he has a spectrometer. Okay, talk about it, Phil.
Yeah. Okay, so the spectrometer allows the spectrometer diffracts the light, so I can tell what the wavelengths are from that's coming from the light from the sun. Okay, I can tell what wavelengths are coming from the sun, and
when
based on the wavelengths that are coming from the sun, and also the spectral lines, I can tell exactly what elements are in the sun. So I know the sun contains helium, and I also know that it contains hydrogen. Now, I also know in what abundance these things exist. Now, I can also know that is a fusion reaction happening, because I know that the sun gives off a certain amount of gamma rays, and I know the sun gives off a certain amount of X-rays, and I know this is only possible in a fusion reactor.
Okay. Whoa, Phil.
Hey, Phil.
Yeah, look, I want to talk about.
So, Phil, those things from getting to us and affecting us the way
they're attacking it.
Phil, does your spectra thing tell how far away? Yeah, spectrometer. Does it tell how far away that light is you're looking at?
Sorry, I missed that. You have to talk a bit louder. I can't hear what you said.
Does your spectrometer tell how far away that light is that you're looking at? You know, when you're looking at the sun, you gave us all that information.
I could use the wavelength and the Doppler effect to work out how far away it is. Yes.
Yeah, but right offhand, it doesn't tell how far away, right?
Well, it kind of does. I can use the information to work out how far away it is.
Water? Can light change when it goes through glass or water? Can it change speed or?
It changes speed.
So how can you tell? How can you tell how far away it is if there are waters above, if there is a dome, then how do you know? See, this is what we're trying to say. You're trying to tell us what flat Earth can and can't do based on.
We have an awesome super chat there from Windrider, who says, "First sip of the glass will make you an atheist, but at the bottom of the glass is the creator." What an awesome super chat. Thank you very much.
You don't need it.
No.
Drop it.
No.
Lose it.
Hand wave. No.
Lose the dome. You don't need it.
No. Fuck off. Lose your attitude.
So, Professor Phil, your spectrometer is not also a radar detector. Like, it doesn't know.
No, it looks at light.
Yeah, it gives you back an image on the screen, right? Right.
No, you look at light. It's actually an optical.
It's not looking at light. It's getting an effect. It's
your eyeballs.
Exactly. Yeah.
It displays
a unique effect.
Diffracts.
I understand right there.
The light diffracts in a prism.
You have a lens, and it takes back information that puts it on a screen in front of your computer. But other than that, you have no idea how far
away that light was, or anything. I do have lots of ideas.
No, you have a belief.
Test it against other elements.
Lots of ideas. He says he's got lots of ideas.
When I point, you know something, when I point,
you should only have one idea.
At hydrogen,
yeah, the globe.
I get the same effect. I get the same wavelengths when I point it at hydrogen and when I point it at helium. I get exactly the same thing.
And how do you know that light isn't going through a dome and the dome is changing it in some way so it looks different? You don't know.
Yes, I do, because if it was in a dome, if it was in a dome, there would be all sorts of other issues I'd know about.
Like what?
Like there wouldn't be a gradient for the pressure because there would be convection currents would
if the sun
overcome
was in the firmament.
You can have a gradient without pressure.
You wouldn't have that because of the heat. There would be an intense heat. You would let's say you believed in creation. That would have been 6,000 years of the heat.
No, you remember what I said earlier about the air compressor? If I put a lighter at the bottom inside the air compressor, there would start to become a gradient.
Have you ever heard of an air fryer?
Hold on. Before I put the heat to
acknowledge what he's saying. Before I put the heat
to it, there was no gradient. It was just one solid pressure.
Yeah.
Now, why I use the lighter? The reason I use the lighter is because it's the sun. And because every day we see the sun and every night we don't, we have a pressure gradient in a container.
Exactly.
Why would that be? Why wouldn't the sun just keep heating up everything underneath it?
The only way you can have gas pressure and the only way to have a gas pressure gradient is to first have gas pressure.
What if the sun keeps heating everything that's underneath it perpetually? It never stops.
But it's not.
What are you talking about?
What's happening?
All we see is...
It would be... Of course it's not, because it's not a dome.
All we see is what we see. We can have stories like that guy said, and all we're going to do is disagree on the stories.
Yeah, we disagree on the explanation.
In reality is
anyway, to answer your question, I know what the sun is.
No, you don't. No, you think you know.
Otherwise, you can make one. It's called reverse.
Hey, Professor Bill.
Yes, probably. Yes. Yeah, we can make a fusion reaction on Earth. Yes.
No, nobody can make a sun. It would make the nuclear bomb obsolete. It would be obsolete.
We can make a nuclear fusion reaction.
It would be superseded if you could make a sun. It would be superseded. That would be the ultimate.
We wouldn't be able to make the sun. The sun is a very big object. No, we can't make the sun.
No, it's not.
We can make. We can make what the sun is made out of.
No, you can't.
Hey, Professor Bell, can you hear me?
Yep.
Folks.
Yeah, I've got a question for you regarding the sun and your measurement of the heat. How hot is the sun?
6,000, I think. Is it? I don't know. I don't try to remember the numbers like that.
Yeah, it's about 28 million degrees Fahrenheit, 15.7.
It depends on where you are. There's the corona, which is pretty hot, but the rest of it's not that hot.
Yeah, the further away.
The core temperature is supposedly 28 million plus degrees. What's the hottest temperature we've ever measured on Earth?
Look it up. I can't remember it.
Do you actually think that something 28 million degrees that far away that you're able to accurately measure and determine its molecular components and the functions within something?
I don't need the heat to measure the components.
I would like to add. Hello, I would like to add to the guy that was just speaking. Where did that heat go, Professor Phil? When if light is a particle wave, whatever, and it's coming to the Earth, where did that heat go? It left the sun at 32 million degrees, and it gets to us at 75, 80 degrees, maybe 110,
So the sun's 15 million degrees centigrade.
So where did that temperature go? Where did the energy go? Where did it go?
Where does the what go?
Space is a vacuum, right? Space is a vacuum, right?
I told you I disagreed with that already, so forget about it.
Okay. So
I told you that there's no place in the universe without gas particles.
Where did the heat go? Where did the heat go?
What do you mean, where does it go?
The heat
it
from
didn't
the
arrive
sun.
at Earth. It did not
Yeah,
arrive
where did
at
it
Earth.
go?
Right?
Into space.
It shines on the Earth.
Okay.
No. He said.
Is there any
Then the
method
difference,
besides
where
measuring the
does
light with the spectrometer that we've used to determine what the sun is?
Yeah, that uses light. Doesn't use heat.
Yeah, is there any other way besides looking at the light that's coming from the sun those million miles away that we've used to determine what it is, how it functions?
That's the best way.
Okay, so you think you can determine what something is simply by the light that's shooting through the galaxy, according to you, through gas clouds, through the atmosphere, which causes everything to look like it's flat, but it's round.
Yeah.
Okay.
And it's 90 million degrees when it hits the Earth's atmosphere. They call it, right? They call it that. But then it diffuses into room temperature. Thank you, Professor Phil.
Do you see how we could maybe think that that's a little far-fetched, Professor?
Look, you just don't know enough about it to be able to make to make that sort of formulation.
We know,
and the only thing that you know is what the light looks like.
Hold on, guys. You guys don't know enough about it.
But we know the same information you know, Phil.
I don't think so.
Okay, tell us something we don't know then. You didn't even know the temperatures when that other guy did.
Oh, that's a good argument for anybody. Like, if you're arguing for Jesus, you could just say, hey, you just don't know enough about him.
Straw man. Come on. Get back on
with
point.
With this gravity well.
Oh, that's what he's saying. That's what he's saying. You just don't know enough about it.
You don't know enough.
Exactly.
You don't even believe in atomic theory, so I can't help you. Sorry.
There's no belief in science. It's empirical.
You don't accept that. You don't accept atomic theory. It's pointless me trying to explain it to you in terms of atomic theory.
Method gets rid of biasness. In other words, belief.
Professor Phil, can you explain atomic theory to us without going through the whole goddamn spiel again? Just tell me how it affects my life and how when I shot a child into my wife, did I shoot atoms?
Look, I told you. If you ask, why don't we just stop it at how it affects your life? Okay. So let's just do that. All right.
I'll give you that. Go.
Okay, how it affects your life? A lot. You're talking to me. How do you think you're talking to me?
From engineering, advancements.
What's that?
Cool.
What exactly is that? And how did the people who made it know that it would work?
Stop asking me these random questions. Come on.
How did the people who made the technology that you're using right now to talk to me know that it would work?
I'll tell you one thing. You don't know.
Sciences.
You don't
know. I know how it works.
I'll tell you how. They use
by practical testing.
No. Let me tell you how. They used applied sciences, empirical sciences that have already been known.
Okay.
Yeah, so you never measure anything else that's 28 million degrees, right? So how would you know how the sun behaves? You don't have anything to measure it against.
Exactly.
You have no experience in that area.
Back on track. Let's say
you want to learn a bit about the atomic theory. Okay.
Let's say you guys use all these applied sciences. You use everything you know. And you did that. Oh my God! You got the interferometer on the sun, everything. How do you know how far away it is?
Transit of Venus.
Yeah, and you assume Earth is a ball, and you assume it's the same size as Venus.
What is Venus? First of all,
it's a planet, of course.
Same size as
you
Earth.
Assume that.
No, I don't need to assume it. You can see Venus.
I don't
you can see it.
You can see it with your own naked eyes.
A round circle. Could
you
be
can
flat.
see it.
And then you go to an observatory and have a look through a telescope.
Still flat.
Oh,
no, it's not.
Round. Yes, it is. You can't see a ball. You don't see a ball. You see something that's flat and round.
No, you can. You can see that it's not a ball. That you can see that it is a ball.
Yeah, I can see it's not a ball. Exactly.
You can see that it is a ball. Misspoke.
Paige. We got to go back and
just like you can see the moon is a ball.
State-created observatories.
You don't
That's what we have to do,
see
Paige.
in 3D like that, Phil.
Yes, you can.
You don't. Your eyes don't see like that.
You have a look with a telescope, and you will immediately change your mind.
Phil.
Have a look at Venus then.
I've looked at Venus. I've looked at Saturn.
And what did you see with Saturn?
A flat thing with some lines going around it.
And what do you think that is?
Hey, Phil.
It's a light in the sky.
Oh, yeah.
Can we tell what the core of Venus is like?
Can we tell what the core of Venus is like?
Yeah, what temperature is the core of Venus? Do we know that?
I don't know. It's not my field.
Do you believe we know it though?
We could.
And how would we figure that out?
Okay, well, we could probably have a look at it from where it is. Consider its gravitational attraction to other things.
Shout out to Silent Zero for the $1.99 super chat. Says trial and error. That's how. No idea what that meant, but thank you very much for the super chat anyway. Much appreciated.
That's what I keep telling you. Science isn't about truth.
We're trying to say we've got different ideas.
Sure. No problem.
Why haven't you told us all this time that you're just a storyteller?
Shouldn't be doing and shouldn't be thinking.
Of course, you can have other ideas. I have ideas.
But you came here saying I'm a flat earther. I'm a.
Yeah, but use your ideas to make some predictions with it. That would be really interesting.
But you don't make predictions either. The eclipse.
Yes, we do.
No, you don't.
Tell me where the comet. Tell me underneath the dome where the comet comes from every 76 years.
Phil.
No. Come on, Paige. Paige, answer this question under your dome. Where does the comet come from every 76 years?
Yeah, it's a.
And how do I know that?
Can I finish?
Okay.
It comes from the sky.
It's a chromatic aberration that the frequency of Earth will give off a certain frequency every 78 years, and it creates an electric phenomenon in the sky.
But it's made out of ice, Paige. But Paige, it's made out of ice.
No, it's not.
Yes, it is, Paige. I'm sorry. You saying no doesn't make it not.
And you saying it is doesn't make it so.
It's made out of ice, Paige.
How do you know that?
Okay. We've even landed a probe on on one of these meteorites.
Oh, my God.
Here we go.
No,
here we go.
You haven't.
Oh, well, what do you mean? What do you mean when you say we landed? When you say we landed, what do you mean by that?
Well, you know, the people who do this stuff.
Yeah, but doesn't we
been to space?
in the English language, doesn't we, like if I said we?
No, I wasn't involved in any of that. That's not my area.
I believe that they did it.
Okay, cool. But he wasn't involved in any of that. Can you tell me that someone maybe who was involved in that?
I don't specifically give any name. Can give you any name right now. No.
Okay, but we saw, but you did see how they landed on a comet, right?
They did explain it. Yes.
They told you a story.
They explained it. Cool.
Yeah. I've got no reason to not trust what they said.
Oh, we've got plenty of reasons not to trust what they say, Phil.
Well, that's you. Stupid. Good.
So, Phil, are you saying
that proof is personal belief?
Phil, are you saying that old Saint Nick's up there on a sleigh being pulled by reindeer?
No, I wouldn't say that.
Why? You got no reason to disbelieve?
Yeah. Yes, I do. I've got plenty of reasons to disbelieve.
What's your disbelief of?
What reasons would you have?
What? Humans can't breathe in up there with pressure, for instance.
He's not human.
At 0.17, 10 to the minus 17.
Santa's not human. First of all, so go ahead.
Well, I don't know. There's no such thing.
Reindeer.
Is this
Phil,
what you believe?
What do you think about Tesla? What do you think of him?
A great engineer.
He was a smart. Sorry.
A very smart, very good engineer, and was very
intelligent,
astute with taking advantage of the technology that was put in front of him.
Please let Paige speak.
The most individual patents.
Hang on, can I just finish, please?
History.
Tesla called Einstein a fuzzy-haired crackpot.
So what?
Well, you were telling us not to call scientists idiots and what have you.
Yeah.
But they've been proven to be idiots.
And at that time, and at the time that this was going on, lots of people disagreed with Einstein. Not that many people disagree with him now.
So stop telling us.
After all the evidence,
Tesla was before.
He's just propaganda. He was just propagated. He was put on a pedestal.
Before Einstein, by the way. Yeah.
Hey, would you guys mind if I ask Dr. or Professor Phil a question? I've been trying to find out, and I've asked a few people, Blue Marble Science and some others, if we wanted to go about falsifying the globe model, if we were looking for a test we could do with an expected result that would falsify the globe model, do you have any idea what we could do?
Sure.
Okay, what?
Put a rocket in space.
I think he wants you to expand.
Put a rocket in space.
Yeah.
Oh,
yeah.
How about
anything on the Earth we could do? Anything to determine that there's no curvature? Is there any test we could do?
Yeah, put a rocket in space.
Hold on,
you guys. You'll test that for certain.
You should go with them here. How much does it cost for NASA to put a rocket in space?
Many, many hundreds of millions of dollars.
Okay, so why would you ask them to do?
How about you give us something that's possible to do then?
So you're saying only people with special
No, you
tools.
just asked. You didn't ask me whether you personally could do it or not. You just said how would you falsify it?
You're going to be a contrarian.
You're just saying only. You're saying only government can go to space.
Yeah, the only people who could possibly falsify the globe is NASA and their friends.
I mean, if you got that much money, you're involved in government, whether you like it or not.
Well, there are private companies who do put rockets in space.
Oh, yeah? Can you name one? Can you name a private?
There isn't.
SpaceX, Blue Origin.
They're funded by NASA.
No,
government
100%.
Oh, yeah, they are.
They're contractors.
Oh, yeah, go look it up right now.
No,
just
they're
contractors who work for the government might as well be the government.
Yeah, exactly.
Just type this in because it's what I
Contractors work for the government. Contractors are paid by the government.
Yes, when they have a government contract,
anything to do with space, is contracted or agencyed by the government.
No, they're not.
Why isn't the ball?
Yes, it is.
There's many private satellites that are put in space that are nothing to do with
There is no fake civilian enterprise to go to space. Come on.
Yes, there are.
Why
do you think if we came up with $100 million that they would allow us to shoot a rocket into space?
Show me Virgin Galactic. Show me Virgin Galactic from 12 years, 2012, where they lost a guy who almost hit the firmament, and they've never been back since. Why? Virgin Galactic.
Who hit what firmament?
The rocket that hit the firmament and came to a stop.
Virgin Galactic in 2012.
You guys are just dreamers.
I don't think we know.
Anyway, I shouldn't say that. I'm a flatty today.
It shows the rocket going a million miles an hour, then it just goes clunk.
Boom.
And comes to a complete stop.
Well, it looks like it hit something. I wouldn't say it hit the firmament. We don't really know what it hit, but it did look like it hit something.
But it hit something and stopped.
But do you think that if we came up with $100 million, Professor Phil, that they'd allow us private citizens to shoot a rocket into space?
Do you see the
Isn't that controlled by the defense
no.
industry?
Your ball model going? Millions of dollars, rockets in space. Give us something that a normal person can do here on the Earth.
Okay, I will.
Your ball.
Yeah. All right. So do this. Would you have enough money to hire a helicopter for a couple of hours?
Yeah,
sure.
I've got a friend who
still got a contact.
Planes, but what's that got to do with anything? You have to be 120,000 feet up to see the curve.
No, we can charter a helicopter. Go ahead. If we chartered a helicopter, how would we tell?
Okay, so this is a way that you can just collect small pieces of evidence, right? You're not going to get the whole lot, so you're going to get some small pieces of evidence put together and make a deduction. Okay.
Cool.
No,
one of the things that you can do
is observation, a test, an experiment that we can do to falsify the globe model. So far, as the
Okay, so do this.
Anything that we come up with that seems to falsify that we would expect to see on a flat plane instead of a globe is then claimed
I would
by
expect to see the Earth moving underneath me when I hover.
Okay, can you do this experiment? Okay, listen to me. All right. So what you do is you grab a helicopter from the ground. Look, go out where you can see the sunset. All right. So and watch the sun go completely. So it's gone. So it's dark. Get in the helicopter, go up 1,000 meters. You'll see the sun again.
God. What does that prove? What about refraction?
No, wait.
Professor? Anything we see on the horizon is impacted by refraction.
Just wait. Hover a while till the sun sets again.
Perspective.
In fact,
back up another 1,000 meters, and you'll see the sun again.
The apparent horizon, so we don't even see the real sunrise.
No. The sun will not have changed its angular size.
How do you know?
You just keep going up and up and up, and you'll still see the sun.
The sun does change. Haven't you ever sat and watched the sun go down over the ocean?
No, it doesn't.
It's absolutely humongous. It looks like 10 times the size of the normal does.
You know that's got to do with the refraction in the air. So that's
here we go.
Oh my God! He just says it doesn't happen, but then it happens because
it happens.
I'm talking about the thing about it is the lot of you sitting over there, Purple U, FAU, BMU, .C, Page. You know what I'm saying. You don't pretend you don't know what I'm saying. Pick up that helicopter, go 1,000 meters, and watch the sun go down again. Wait till the sun goes down, go another 1,000 meters, you'll see the sun again.
Do that. How could we be sure that the sun's not setting behind the apparent horizon, since we never see the real horizon?
You don't know what I'm talking about.
Works on a ball.
So hold on. Let me say something.
Well, that's good.
Hold on a second. If you put a clothesline on a chessboard that's 100 miles long, right? And you hang a light bulb on the clothesline, you make sure the clothesline's tight, so it's always the same height above the chessboard. And you have your friend push the light bulb out. It's going to look like it's going down towards the chessboard, right? Yes. But it's staying the same height, right? Yes. And if you raised an elevation, as soon as the light disappeared behind the horizon, you would see it again.
Yes.
So that
is the same thing you can do on a flat plane.
You could do it on a flat plane, is all I'm saying.
Yeah.
At local distance. Yeah, at local distance.
Aren't us flat Earth people supposed to be saying that the sun goes away? Doesn't the sun go away?
Yes.
Isn't that what I just said?
Well, how come it's not changing the angular size if it's going away? It should be getting smaller and smaller.
Because it's not one, it does, and two, it's not a physical object. It's an effect. Only physical objects will change in size.
So the sun's not an object?
Get smaller. If you want to see the sun,
we don't know what the sun is.
Go to the desert.
Do all of you agree on what the sun is?
No,
bro. All you see is a light in the sky. How are you going to tell? You're going to pull out your little machine, and it's going to go beep boop beep boop beep boop.
All right, let me just try this little experiment. Okay, there's 5 of you there. The one with the purple. What do you think the sun is?
Chris.
Okay, so I will state it. Just you're asking us our personal opinions, just so you know. I believe the sun is made by intelligent design so that we have a night and a day. That's why it works so beautifully. It is. It's just the light from the creator. It's not anything. It's not like a thing. It's just. It's if it was perfectly dark, you'd bump your head into things. So he's like, okay, I need a light. So he made a light, and then he was like, well, I need a light in a day because it sounds stupid to go to sleep when it's bright out. So then plants are also photosensitive. Then you have nocturnal animals. It's by design. So the sun is a light that works by design.
It goes too far away to see it, Phil.
Is what physical.
They drop.
Where does it go at night?
It's you just at night you can't see it. It's somewhere else.
Why can't
I tell you what I think it is?
It goes away from your view. Very simple.
Okay, so does it get smaller and smaller as it goes away from your view?
It goes away from your view, just like everything else goes smaller and smaller away from your
size,
view.
Bigger and smaller, depending on
does it turn into a little dot and then just disappears?
Yes,
no, the atmosphere is too thick. It fades out from view before it can shrink that much. But it will actually enlarge as well as shrink, depending on
how come you can't see the sun anymore, but you can see the stars? through the same atmosphere.
What is daylight? Tell me what is daylight?
The stars are
why do you say they're in the same?
You're using the Bohr model.
What is daylight?
Both of them at the same time, Professor Phil.
I was actually onto the first. I'm up to FA now. FA.
Do you ever see the sun when you see the stars?
All right. Can everybody be quiet and just FA tell me what you think the sun is?
Do you ever see the sun when you see the stars?
You can't see the sun and the stars at the same time.
Professor,
so how do we know the relationship between them?
How do you know they're in the same area?
Well, you see, when the sun disappears, you see the stars.
Yeah, when the sun's no longer in the picture.
When sunlight is no longer in the picture. Sunlight.
Yeah,
sunlight. You see the stars.
Sun and sunlight are different things.
So where did the sun go?
How can you say they're in the same area?
Stop asking the same fucking question.
How do you
where
say
the sun used to be? Where the sun used to be, I can see some stars.
Yes, because there's the light from the stars is brighter than the
sun.
air around you.
The stars are brighter than the sun.
Is that what I said? You fucking
sounds
moron.
like what you said.
No, I said the stars are brighter than the air around you now. The sun's gone.
That makes sense.
Fucking ears.
That makes sense. Now, where did the sun go?
Over the other side of the earth.
Okay, so it gets smaller and smaller as it goes away?
I explained that. It gets bigger and smaller depending on how much water is in the atmosphere, how much of a lensing effect you have.
Yeah, but so it should go down. It should end up being a little dot, right, at some stage?
Yep.
Did you hear me? No, there is water in the air which will magnify it. So it will never, the atmosphere is too thick. It will never get far enough away. You won't be able to see it. The angular size and the lensing effect in the atmosphere, how thick the atmosphere is, will never allow you to see it get to a dot.
So does it just turn off then?
Oh,
yes.
Oh, hold on. It does. Hold on a second.
Are you kidding me?
If you go to the
desert,
we
call a rampage. She's good.
If you go to any desert, right? Any dry climate, real dry, like the desert, right? You will see the sun shrink in size as it goes away.
Okay.
Now,
it'll be easier to see in a desert.
Let me finish. If you have more water in the air, it actually magnifies it.
Yeah.
Yep.
So it could be that it's appearing to stay the same size because of the atmosphere.
Yep, apparent.
But I'm
in the desert, you will literally see it shrink in size.
Okay, so it stays the same size, but what? So it just keeps going, and then does it turn? How does it turn off?
It never turns off.
But it gets dark. It must turn off.
What
makes you say that, Professor Phil? What makes you say that it must turn off?
Because it's got dark.
How do you know it just didn't go too far away for its energy to reach you anymore?
But then if it went too far away, I'd see it get smaller and smaller and smaller till it disappears.
We just explained that.
So at some stage it just goes, does it? It just disappears?
Hold on a second, guys. Does the street light light up the whole Earth?
No.
No. That's what the sun
is like a flashlight above the Earth. It's close enough.
Yeah, but the street light's got a lampshade.
It's not a giant nuclear.
Wait, he said the street light has a lampshade. Wait, he said the street light has a lampshade. That's why it doesn't light the whole Earth. Oh my God, Phil, you're going to save us millions on the highway. They just make one light, remove the shade.
It needs more light than that. But what's that got to do with the sun? How come it gets dark?
Because the sun is a light. It behaves the same way.
It's local.
It's not as
but you still haven't explained. You said the sun does not get smaller and smaller. That's what you said. Is that right?
The apparent.
Right hand. He just said the sun does not get smaller. What do you have to say about that?
Okay, regardless of whether the sun gets smaller or bigger or larger, when you stand in one spot and watch the sun set, that's the effect, okay? Whether it gets bigger, whether it gets smaller, the sun shouldn't do anything because it just does what it does. So
what kind of answer is that? Where does it go?
Well, let him finish.
Phil, when you say, where does it go? What you're doing is me and you were standing in a spot. We see the sun disappear. You look at me and go, hey, what do you think happened? And I go, I don't know.
Yeah.
Maybe it went
tell me your
too
story.
far away. And you go, well, I think the Earth is a ball that's spinning and we're in space and the Earth is going in the opposite direction. So I'd be like, okay,
you know
that's
why?
right, man.
Because if I go up in a helicopter, after it's gone, I'll see it again.
Okay, hold on.
We already talked about that.
Yeah, Phil, that's the exact. Okay, here I'm going to address that. And okay, so now me and you are in the helicopter, right? We see the sun again. You go, and you look at me and you go, "Why do you think that happens?" I go, "I don't know. Probably because we went higher." And I go, "Why do you think that happens?" And you go, "Well, because this Earth is a ball and it's spinning." Like it's just a story. You're just you're telling me a story.
Yeah, no.
Yes.
I'll give you a handshake and say, "Well, that's pretty brilliant of you to figure that out."
Okay, but no, when you say figure it out.
Hold on. When you're in a helicopter, you rise up and you see the sun again, right?
Yep.
Why is the horizon still flat and you're claiming it's a ball?
It's just how it looks to you, that's all. Because you're looking at a tangent.
That's how it looks.
Oh, okay. Come on.
So now you want to disregard how it looks, even though you're asking where the sun went based off how it looks.
That it should be
You're looking at a tangent.
So we see it behind the curve, but then we go higher, see more of the Earth, but horizontally, which should be even more curved than it is forward now.
If you keep going, you'll keep seeing the sun.
Oh my God!
How come? Isn't it supposed to be going away at some stage? When does it decide to go away?
The horizon.
And it gets too far away for the sun to light us.
Every time we go up another 1,000 meters, we see it again. How come?
Phil,
why does it go away?
You keep asking why. He just keeps asking why. And the thing is, his religion has this, well, because the Earth and this and that. My religion says because God designed it that way. Now, if you're when he asks you why, hold on.
God designed it that way. I'm just asking, how did he design it? What did he do?
Let me finish.
How are we supposed to answer
when he asks us how, if we don't give him what his beliefs are, he's just going to tell you you're wrong.
Yeah, exactly.
Good call.
What?
Dan, good call. He's
Phil,
always asking why.
Because he wants you to go, I think it's because of this. And then he'll say, no, that's wrong.
Yeah.
It's because of this.
Yep. He has no.
Because you're in a religion, Phil. You're in a religion, buddy. You're in a religion. Space, science is a religion. You have a Big Bang. We have God. You have evolution. We have creation. You're in a religion.
Ranty, this has been great for you. I can see the super chats being firing up.
Hey, Professor.
Well, Phil, do you admit you're in a religion?
You never did tell us how we could falsify the globe.
I did. I told you to get up in that helicopter. That's one way. If you go up to that helicopter, this is how you falsify it, all right? You get up in that helicopter. Listen, Paige. I'm telling you how to falsify the globe, all right?
First of all, Phil.
Oh, these guys. From Godzilla. Yeah, well, if Earth was flat, why don't I see any curve? Well, indeed, that is the question. And again, oh wait, from Godzilla. Yeah, obviously, because we don't see any curve, because there is no curve.
You falsify the globe. You get in the helicopter. You look at the sun. You wait for the sun to go away. You look at you go up again, and the sun has gone a bit further away, and it's smaller.
That's the best proof you
go up
have.
further, and the sun is smaller again. Now you know that you're not on a globe.
That is a
no. That just means we can see. That just means you can see the sun when you go up in a helicopter.
That whole time.
No, it doesn't. It means the sun's going away from you.
It means I got a helicopter and I saw the sun.
If the sun just dips below the horizon, you know you're not on a flat surface.
About your apparent horizon.
It has nothing to do, Phil, with what Phil's trying to point out. Like, it's a globe Earth, and I just went up in a helicopter and I saw the sun. Great, right?
Yeah, but no curved horizon. It was flat. So
can I just say, for a professor, that's totally unscientific, Phil, because you're after invoking the sun and you haven't defined what the sun is.
Exactly.
I have. You just didn't agree with it. That's all.
No. If you were pretending to be a flat earther tonight, excuse me, please. If you were pretending to be a flat earther,
being a flat earther, you mean?
Hang on, please. If you
I just accept what the sun is in any case. I'm not going to argue with the sun. I can accept that the Earth is flat and the sun is what it is.
Well, hang on, please. If you were pretending to be a flat earther tonight, why would you carry in the idea of what the sun is in a ball Earth model into a flat Earth model, and then discard it on the
then you don't have
basis
to
that it
argue
works
with the
on a flat
ballers.
Earth model?
That's what I've been trying to tell him the whole time. Why are you using the ball model? Your beliefs of a ball, what happens on your ball? Why are you using that to explain flat Earth?
Because then you don't have to argue with the ballers then.
Phil, we don't give a fuck. That's our whole point. We want to argue with you because you're wrong.
Can I want actual proof, evidence? We don't want stories, Phil.
Let me just say something regarding Phil said himself, a street lamp has a shade, right, to cast it through the light. Well, what's to say that the shade for the sun is not the barrier itself, Phil, and a particular contour and makeup of the barrier?
Yeah, exactly.
It would need to have a semicircular shade, wouldn't it?
Well, it does. It has an oval shape, actually, Phil, and it's we're divided into two barriers, an inner barrier and an outer barrier. The outer barrier is highest along. Hang on, Phil. You haven't considered this, you see. So how can you rule it out? I said the outer barrier is highest along the equatorial areas, right, and low at north and southern peripherals. You haven't considered that, Phil. All the skylights are reflections, right, off of this watery energized barrier.
Now, I've looked at the sun. I've looked at the sun hundreds of times, if not more, with a filter. It's round.
Look at the sun from high altitude. Excuse me. Look at the sun from high altitude balloon footages above about 60, 70,000 feet, and you'll see a very different sun to the round one that you see through these filters.
No. Yeah, how does the sun
that's away from the water in the atmosphere, right?
No, it's the sun looks the same wherever you look at it.
Your mind is made up. A recent
3 million miles away, create a hot spot.
No, I'm just realistic. I don't make stuff up. So you guys just want to make stuff up on your way.
Here, wait, Phil, hold on. You asked for explanation. Pete gives you an explanation, right?
Yeah, but it's
and
just,
then you're just like, he says, hold on. Pete, you said you never seen the stars and the sun at the same time. So the stars can be a reflection of the sun. That makes sense, especially if you don't see them at the same time. So
no, how can the stars be a reflection of the sun if the sun has gone to the other side of the world, according to you?
Well, isn't a reflection that's the whole point of a reflection?
But why should we have to sit here and guess what everything is with the sun and the earth?
He keeps saying why.
No, you just make things up as you're going along.
We don't need a story.
Well, that's the point.
Well, because your story's been made up already.
Hang on, please. Professor Phil here, in a scientific sense, has not considered the alternative. So he's ruled it out. So that's why it's pointless talking to this Professor Bell.
No, I don't understand what your alternative is, Pete.
Okay. You haven't heard it, man. You haven't heard it.
I heard what you said, and it just sounded like word salad. I couldn't make out a thing about it.
Phil, let me say this. Would you agree, Phil, at the heart of any scientific endeavor is the height of skepticism? You always have to be skeptical about everything.
Absolutely agree with that.
Right. So you have ruled out. Excuse me, please. You have ruled out a flat Earth possibility on the basis.
No, I haven't. I'm here trying to be a flat.
Excuse me. You've ruled it out on the basis that it wouldn't work in a helicopter ride.
Hey guys,
to be a flat earther.
Let
finish. Yeah, I just wanted to finish my statement. You've ruled it out on the basis that the flat Earth is impossible because of what we see regarding the sun, but you failed to define the sun in the flat Earth sense.
When did I say that? I came here to tell you that I think the Earth could be flat.
What? You just said the sun goes over the right. It's got to be a ball.
Wait a minute. What do you mean, Professor Phil? You're saying the Earth could be flat? You think it could be flat, genuinely?
Didn't I? Did I come here and I said this is what you need to do if the Earth is flat?
Don't need you telling us what we need to do. You're trying to get us.
Yes, I do, because you're mucking it all up. Of course, I need to tell you what to do. You're mucking it all up.
Well, hang on, Phil. When I tell you, hang on, Paige.
Because you're mucking it up.
Stop shouting, Phil.
Care.
Hang on, Paige. When I tell you, Phil, hang on, Paige.
Is nothing.
Can I?
You're buggering it all up.
Why Australians are very loud. Can I say something to this guy, Phil, please? One moment. Phil, I've been a flat earther for the longest time, and when I try to express in a very sort of brief sense my developed ideas on what's going on with the skylights, you call it gibberish and word salad and immediately diminish it.
Because I know the sun doesn't have a semicircular lampshade.
Okay.
How do you know that?
How do you know?
Because I've seen the sun heaps of times with a filter.
Okay, cool. So how do you know
what's behind it?
Yeah, if you were living under the lamp and you looked up at the lamp, it would look like a circle with the shade over. You wouldn't see the shade over it. You would just see the light under it.
Not if it was semicircular.
Wait a minute. It doesn't matter if it has a lampshade or not. If I take a huge bright spotlight and walk away from you, eventually that light will not reach you. It doesn't have the energy or the power.
I agree with that. And that light will get smaller and smaller and smaller.
Every time. How do we know it doesn't?
Easy, everyone, easy.
I couldn't talk. That's why I was telling Pete, good luck.
I know. Easy, everyone, easy. Is it our turn or his turn or whose turn?
Right, I'm just going to wait until people ask me a question. Okay.
That'd be good.
Okay, go ahead.
How far away is the sun? Yeah,
93 million miles.
Okay, and how do you
150 million kilometers.
How do you know that? For
transit of Venus.
Okay, so you're using how do you know how far away Venus is, or?
By a two-point calculation from the Earth. So standing at two different places on the Earth, looking at Venus and looking at the triangulation.
And when you're looking at Venus and you're looking at the sun and you're making these calculations, what are you basing your end reference off of? Like,
well, first of all, you've worked out how far Venus is. Okay, because you can see the size of Venus, and you can also you know your 2 points on Earth. You know how far apart you are.
You can see the size of Venus. Of course you can.
Yeah, of course you can.
Yeah, hold on. So you've got a line of thinking here. So go ahead, Aaron.
How do you know how far away Venus is before you take that measurement of its angular
triangulation?
Size okay, cool. How'd you triangulate that?
2 points on the Earth. Look at Venus. Different people looking at Venus. Measure the angles.
Or lasers, or how did you triangulate the distance to Venus?
I'll articulate how he did it since I'm a foot. So what he's going to do is he's going to take two people in separate points on the Earth. He's going to have them point a telescope or object at Venus. Now here's where the magic trick comes in. They never measured. Hold on, watch this. They never measure the angle to Venus. They measure the angle that the telescope makes with the ground.
No, they measure the angle to Venus.
No.
You measure the two of them. Where the two meet, that gives you a pointed angle. The other two angles, and then you've got a distance. You can use the cosine rule to work out what the.
Okay, Phil, I understand it, but you're not listening to what I say. Now, when you say when you say measure the angle, what you're going to do is you're going to point something at Venus, right, and then measure the angle that you're going to take a line through what you're looking through, right, and measure that angle to the floor. Correct?
Yep.
And since when do triangles have curved lines?
Exactly.
The bottom of a triangle.
And hold on, Phil. You're looking through the atmosphere. So are you looking at the geometric location of that planet, or are you looking at the apparent?
Yeah.
Go,
How
Phil.
do you measure it?
It's so far away, the difference doesn't matter.
It does not.
Here we go.
Okay, hold on. Let me give him an analogy. Hold on, guys. Hold on, guys. Let me give him an analogy. If I took a target.
I'm just going to give a quick shout out again to Godzilla for smashing the super chat, who says, Phil, Black Swan, all we need, you are finished before you started. Awesome set of pictures, I have to say. If you haven't seen the Black Swan set of images, go ahead and have a look. Definite globe killers.
Okay.
Do you think that you'll get the laser light on the target, or you'll see where it's at and then move it over?
I'll probably have to think about refraction, perhaps. Yeah.
I think at 1,000 yards, I think it would be off about 3.5 feet.
Just like spearing a fish in water. Remember what I said, Phil?
Okay, so what?
Hold on, let me finish. You could even put the damn it. The ruler that you use for your angle, damn it. Come
protractor,
on,
James.
Protractor. Thank you. You could even put the protractor, at your barrel or whatever, however you do with the telescope, right?
Mm-hmm.
Now, you miss the target with the laser, but you see the laser, so you move it over to the target, right? And that was at 1,000 yards. So at one astronomical unit, if you was off 3.5 feet at 1,000 yards, how much off would you be at the star?
Oh, yeah. No, you have to calculate it.
An awful lot.
I don't keep these figures in my head.
You would actually be. You would actually be.
Critical thinking.
Let me finish. You would.
FE News says he's impressed with the FE debating skills. Sorry, he's impressed with the debating skills of the FEers. Indeed. So you should be. We've had plenty of practice.
You have its exact location, don't you?
I think you could make a calculation so that you can work out exactly where it is. Yeah.
Enough said.
Phil,
just
think about it this way. If you know how you said when you try to spear a fish in the water,
yes,
you won't hit the fish because it's actually in a different position. Okay, the same thing. Think of it in the opposite way. You're looking up through water instead of down into water.
I'm not arguing with you about Paige. Why are you arguing with me? I'm not arguing with you about that. What's the problem?
You are. That's the whole point.
No, I'm not.
So you agree now that you can't...
Yeah, I would just take the refractive index into account and I'd be able to calculate exactly where it is.
Phil, how are you going to get a refractive index for 6 billion light years?
Exactly.
Come on, dude.
Phil, I told you know that no refraction happens after the atmosphere, Phil.
It doesn't matter how big the number is.
It doesn't matter how big the number is.
Honest.
Actually, that's a really good. Hold on. That's a really good question. How are you going to get the refractive index for 6 billion light years?
I already know the refraction index for atmosphere. What are you talking about?
No,
what about past atmosphere?
6 billion light years.
Yes, it would be very, very small because that's a bit different going up than it is going across.
There's still atmosphere in space, though. You gotta if you think there's
the refraction there would be very tiny.
Wait, but hold on. Even if you think there's only a few atoms per cubic inch, whatever, I'll give it to you. Over the course of light years, they are going to add up.
It's not that all the way.
How do you know? Have you ever validated any of the distances?
There you go. Another assumption.
If just let's say, for instance, I'm not saying this is the case, but I'm just giving you an example. If it turns out that the sun was that we were out a little bit because of the refraction, and the sun turned out to be 135 million kilometers instead of 150, would that make a difference to you?
Yeah, it would make a difference.
Why would it make a difference?
Because it would throw the whole model off.
No, it wouldn't. It would be
it would mean you guys don't know what you're talking about, and you're basing your beliefs on assumptions. What you are.
Exactly. If you're wrong about this, what else are you wrong about?
You've got this idea in your head that I care about something called truth. I don't.
There we go. Thank you, Phil.
Bingo.
It was all like
I want to. Hold on. I really want to agree with Pete here. Can you even prove that there is enough space for 1 million miles?
Yeah. I don't need to prove.
Well, you do. If you're going to tell me something 6 trillion light years away, but you can't even prove that 1 million miles away is possible.
The calculation that I can make.
Calculations are just that's math language. That's math
the
language.
Distance to the sun. So yes, there's enough space between us and the sun.
Phil, math is a language. Yeah,
your calculations are totally meaningless if it's not the truth. And yes, we do want to know what the truth is, and it does matter because you guys go around teaching all of our children what the world is, what it's about, that there's nowhere else for us to go, that there's no God, that we all came from nothing, based on these assumptions that you have.
That there's no God.
And again, you interrupt. You just can't help it, can you, Phil?
No, but you talk bullshit along the way. I've got to stop you.
Hold on, guys.
No, you don't. Shut your mouth and let people finish.
if you're going to be rude to me,
hold on, guys. Before you get into an argument, before you get into an argument, I just want to shout out Aaron Moorfield, who's actually on the panel, who says it's fun to be here and a great show. Thanks, Ranty. And SX0 says he said there is always air in space. Right.
Yep. Always gas.
Can I ask Professor Bill here, whatever? Can I ask you a question? All skylights appear from our earthbound position to revolve around Polaris, right? Let me hang on for let me just say this. Let me just say this, Phil. And Ranty, I'll just take 30 seconds and I'll go, maybe a minute, and I'll go then. But I'll just give you my overall picture as to what's going on. When you talk about Venus here, I think it's particularly clear in these nights that Venus is a direct reflection of the moon. The moon itself is a reflection of the sun, but as all skylights revolve around Polaris, hang on please, let me finish. This is the central projection, right, of something that is earthbound and is the source of all of these skylights, which is Aristarchus itself. So when we think in these new sort of close-up terms, well, we do away with the need for millions and billions of miles, and we see everything in a completely different light. But we have to consider it first, right? On that note, I'm going to head away, and thanks a lot. Speak to you later. Suck up and toilet roll. It was too late for me here.
See you later, Pete.
Hey, Pete, thanks. Thanks, Pete. Pete, thanks for showing up, man. You're a great guy. I love your input. Everything's cool. I'm Aaron. So.
But even at a lower level, Phil, you can't prove your base assumption, which is that the ground that we're on is curved. All these measurements and the angles that you have are based on us standing on an Earth that is curved at 8 inches per mile squared, correct? We can't even make an observation standing on land to solidify that.
Not if you're standing on the ground, you can't. But you can look at you can look over the sea, of course.
Well, we did that, and we showed you these pictures that we can see way too far for the globe of the dimensions, and you told us that's how the model works. God dang it, Phil,
just
stop.
Forgot about the looming, didn't you?
You told us that is how it would work on a globe model. So any observation that we see that shows that there's no curvature, you claim.
I don't want to tear
you just let me fucking finish. I won't talk forever. I'm done now. Go ahead.
I came here to try and help be the flat people, okay?
We don't need your help, Phil.
See, there it is. There it is. There it is.
No, this is it. You do need my help. He thinks you're not doing a good job on your own.
Paige, it's okay.
He thinks we're just too stupid to understand the ball.
No. Well, you definitely don't understand it, but and it's nothing to do with
who determines whether I understand it, Phil?
Because they don't understand.
I don't call anybody stupid. But here's the thing. Who determines understand? If I rattled off the distance to the sun, which I know 93 million miles away, I know the distance to the moon, 200, blah, blah, blah. If I start rattling these things off, does that mean I understand it? Or I've memorized some stories that people told me?
You don't need to memorize it. You can actually do that experiment yourself.
Answer the question, Phil. Does that mean you've understood it or you've memorized it?
Wait, no, that's you can. People have made this mention, and I accept what they say.
What does understand it mean? What does understand mean? That means I've accepted the story you told me. When you say
it means
understand,
that you know how triangulation works.
Okay, but
to put it better, what they're trying to say to put it better is instead of just verifying what they've already given you, have you ever tried to falsify it?
Have I ever tried to measure the distance to the sun myself?
Instead of just saying, yeah, if I do this and I do that like they say, I come up with this just like they said I would. Yeah. But have you ever tried to do something to falsify it?
Yeah, like actually do the experiment and it works.
Like flat Earth.
Well, yeah. Well, like a real scientist, they don't go to prove things, they go to falsify, really.
Yeah, you just do the same thing you were told to do. Have you ever tried, to falsify it, to try to prove it wrong? Or do you just do exactly what it says in the book?
No, you triangulate, and if the figures are right...
Yeah, you do what it says in the book. Thank you.
You don't listen, Phil. You answer the questions you think have been asked.
I know exactly what's been asked.
Then you obviously obfuscate on purpose, if that's the case.
Okay, hold on.
I told you how they measure the distance of the sun.
Hold on.
Either you accept it or you don't. It's not up to me.
I'm going to clarify this. Phil, we're going to clarify. You didn't measure jack shit, okay? What you did was calculate. Now, when you measure something, you take a standard empirical unit that has been standardized and calibrated, and you use multiple of them to get a measurement. What you did was calculate based on rates.
Okay, right at the hand. And he also did that in what his example towards, today, to calculate the distance to the sun, called radiometric data, or what did he call that? Interferometer.
Spectroscopy.
Spectrometer. Thank you for
listen, I've got to go. So ask me some other reasonable questions. Go on.
But you can't do that.
Yeah. Hey, Phil, I have a question for you, bud.
Yeah.
Do you like how Professor Dave likes to use a fallacy of where if the Earth was flat, we should be able to see China 1,000 miles away?
No, I don't accept that.
Yeah. So why would they do that, Phil? Why would they use plain mockery and pure fallacies to defend their model?
Well, that's them.
Answer the question, Phil.
I don't know. I can't read other people's minds.
Is it because they don't actually have any science, Phil?
Well, by definition, it's actually called zealotry.
Yeah, I know, but listen, Phil.
Yeah.
It's proof right there. It's fallacies in that video. Everyone after it, mocking the whole idea of vision, all for the purpose of what, Phil? To keep the lie going. It appears the case to me. Why else make a video like that?
You're doing exactly what they. You've just done exactly what they did.
So don't turn it around, Phil. Phil, don't try to turn it around, bud. Don't try to turn it around.
That
it's spectroscopy. Come
yes,
on.
we get it.
That that's a piece of propaganda, Phil. If you're not a fan of it, why aren't you a fan?
Why aren't I a fan of who?
Is that Professor Dave video propaganda?
I like Professor Dave. What are you talking about?
Is it propaganda?
So just go back. So Phil,
I don't have to agree with everything.
Now
you're
double speaking, bud. Now you're double speaking. 1 minute you said you didn't agree with it.
I like what some people say, but it doesn't mean I have to agree with everything they say.
Okay.
Well, why don't you like
the point of the question, Phil? The point of the question, Phil, is why would they do that? And you said, well, I don't know. Can you come up with a better reason why they would use fakery and mockery instead of actual real science or a real argument?
So the professor says you should be able to see China from where?
Basically, the overall mocking state of our vision is that if the Earth was flat, you'd be able to see 1,000 miles away. This is not just.
I guess that would
depend with infrared, but anyway.
Let him finish.
Professor Dave is going around using fallacies like this to back the argument. I asked you, what would you think about that? You said, well, I don't agree with that. Then I asked you, why would they do it?
Well, why would I know that?
You, sir, are a grown adult that is now debating on flat Earth channels. You've now taken the time out of your day.
And how smart you are all day long.
Even if I speculated, why, it would still be a speculation, wouldn't it?
The best part about it, though, Phil, is your acknowledgement of it. That's why I asked you. The fact that you're acknowledging it is half the battle.
Okay.
The problem is that there's not enough people admitting. Yeah, he's a fake professor, by the way. It's not even. It's just a catchy name, by the way. They're everybody calling themselves professors. Phil, how far is the horizon from your eyesight? By curiosity, do you even know?
Well, it depends on the day.
Your height, sir.
Okay,
your height. How far away is the horizon from your eyesight, Phil?
I'm under 6 foot, so not much though.
Yeah, but how far?
So how far would I see the horizon? I don't know.
Why does it take
miles or something like that?
That's a question to get an answer.
Just let the guy answer the question, man. So listen, Phil. Everybody just talked over you. How far is the horizon from you?
Around about 3 miles everywhere.
Awesome. What would you think if I told you I've been going around door to door, literally, interviewing white coats, let's call them, just to put a category to categorize them all. Most of them don't even know how far the horizon is from their own eyesight. Now explain to me, they think the Earth's a ball. They think the sun goes down past that point. Do you know the awe? Do you know the awe, their jaw-dropping moment when I tell them it's only 3 miles from their vision? They can't believe it. Why is that, Phil? Why did we not teach people the proper way to view our vision? Why is it getting hijacked?
Because if they did, we'd know it wasn't a ball.
Well, I understand that, Paige. We understand that. But I'm just asking him because Professor Dave likes to mock our vision, right?
Yeah.
They like to mock the shadows. They like to mock the shadows.
Vision, if they taught
I still don't understand your question, but
we would all be eye doctors.
The question was originally is how far the horizon was from you. The point of me asking,
I gave you that. Yeah.
The point of me asking, it's based on your vision. Yeah. Another question, Phil. Can you calculate the distance to the horizon using the angular diffraction limit of the human eye?
I don't know it. No, it's not my issue. So I don't spend time on everything.
I'm here to tell you they can.
Yeah,
the horizon has nothing to do with an edge.
I don't know.
The horizon has nothing to do with an edge. Do you know what the horizon is? Do you know what the horizon is, Phil? It is the Ari's disk compressed into the center. Basically, 3 miles away from your high sight, there's a 2 foot, 3 foot crest wave that's being compressed into your vision. It's causing a blur. If you do the math and you use the Rayleigh criterion formulation, but this will use an angle of 0.007, we'll times it by 3.14 divided by 180. And you do the distance, whatever your 3 miles, you got a 2 foot airy disk blur that's compressed in the center of your frame. It's an optical diffraction point of our vision. I was in the optometrist today. Listen, bud. I was in the optometrist today. Listen, bud. Stop interrupting me. I was in the optometrist today asking them. I said, listen, a lot of people don't understand the refractive index of 1.44 in the human eye. I says a lot of people don't realize that it rises the floor up into the center focal point position below the center point, and it lowers the center focal point position. So you have a refractive index of 1.44, and you have a limited diffraction system of 1.22. The light of angles are causing the edge of
Hang on, I'm going to take a call.
Yeah. See. Anyway, thanks for Randy. Thanks for letting me in. I'm out too. I just wanted to get.
Hey, great job. Great line of questioning. Man.
That was spot on. Yep.
Yeah. No
Cheers,
worries.
Guys. Thank you.
Yeah. No worries for stopping by. Thanks. Shame that the phone call came in.
Flutter Theta.
Yeah.
You didn't call Professor Dave Professor. You actually called him Dave one time, so he's hurt. Yeah.
They're called professors because they profess everything.
Yeah, exactly. So he's all hurt right now.
Wise, they became fools.
Exactly.
He's all hurt.
What I want to know is if they.
He said, "But my title. If
the Earth is sitting in a gravity well, right, like what they show with that bit of fabric where they have the ball in the middle and it's dipping down. How does the atmosphere stay, above it and on the sides of it? How come the atmosphere doesn't fall into that well as well?
All right, so can I just stop you for a second? You'll probably want to hear this.
Right, go ahead.
Sorry to interrupt. I just got a phone call. It looks like one of my colleagues hasn't shown up for his lecture, so I'm going to have to go and take his place.
All right.
So
hope he doesn't have coronavirus.
So thank you all for putting up with this new flat earther. That's me. Okay, I have been trying to help you, and you've got a lot of work to do. Well, we, flat Earth have got a lot of work to do to make this legitimate. Okay.
What do you mean? What do you mean? Say it.
Well, I went through it before. Listen to the tape. You'll see all the things that we spoke about. Start off.
Hold on now. Hold on, because the truth is like a lion. You don't have to defend it. You just let it loose. It defends itself.
You've got to build it. You've got to build something that you can use to make predictions.
No, we don't got to do nothing, Phil. We've proved your ball wrong. That's all we've got to do.
No, that's not going to help. What use are you to the world?
Prove your model wrong. That's
what use are you if we can't use what you know to make any prediction? What use?
Most of what we know is what you know, Phil.
And walk before you can run.
We already know what you know, Phil.
You don't live on a ball.
Yeah, good.
First.
Well, use what you
know. We already know. Yeah.
You need to be useful.
Yeah, and so do you, and you're not.
So what do you do,
Well, we are all the things. Look at me. You're talking to me over technology that was created by people who understood,
but not by
who
you.
understood
It was
atomic
created
theory.
by us.
Is that technology based on the shape of the Earth, Phil?
I'm talking
Would
about
computers work on a flat plane? That's a ridiculous non sequitur, red herring.
There we go.
There we go. Very good.
You know what? It's been nice to talk to you, Phil, but it'd be nicer if you answered questions in a straightforward manner and we're a little bit more honest.
Look, I got to go, so it is what it is.
Oh, gotta go.
Get near the end of their
I told you I just got a phone call. I've got to take over someone else's shift. So
I'll see you later, Phil. Thanks for stopping by.
Phil gave us a lot of time. I give him props. Give him
Yeah,
props. Phil stayed a lot of time.
It's been 3 hours, and that's a long time. All right.
He hung himself very well.
Yeah,
Cheers, Phil.
I thank Phil.
Cheers, Phil.
Gave us good conversation. Thanks, man.
All right. Catch you guys later.
I appreciate it.
See you.
So, Randy, are you still around?
I am. Yeah.
Hold on. Who was it that just said? Is technology based off the shape of the Earth? Who was that?
That was Brandon.
Lots of technology is based off the shape of the Earth.
Respect. Much respect to whoever said that. That's great.
It's not.
Lots of technology is based off the shape of the Earth. I'll just leave it at that.
Technology is not based off the shape of the Earth.
Yes, it is.
No, it's not based off that. They might.
Well, then it would be flat.
Way, but it doesn't.
It would be flat if that's the case. Do you know what direction radio waves travel?
Straight line distance.
I'm trying to stay away from satellites, but there you go. All right. See you later.
See you later.
Did I say satellites?
He had to say it once.
I thought I said radio waves. I could be wrong.
No, you said
he wants to say he's a flat earther, but then says satellites are real, right?
Well,
satellites are real. It's just they're on balloons.
Balloons, yeah.
So like the ISS is like it works because they launch one at a certain time in the morning, right? And it only goes so far, and then they launch another. So yeah, you can see.
See, the problem is because they think they can see stars that are billions of light years away. They think we've got Superman vision. This is why they think they can see. They should be able to see the sun when it's on the other side of the plane. Why we should be able to see Africa and Australia.
I think the best thing I learned tonight is it's just storytelling. I could tell
They've spent 500 years getting that story together.
Yeah.
But they want us to have a Just So story done in 5 years.
Yeah, the only problem is they have an echo chamber of the same story.
But what if we could all, survive here on this flat plane with small towers? Small towers, right?
They did it. I think it was
we've done that. That's what we're doing. Right?
Yeah.
No, hold on.
I'm communicating with you right now. Small tower. That's all we're doing.
The first ground positioning system, I think, was Project Loran.
Yeah.
And it was based off triangulation of a flat stationary plane.
There is a complication. How do I get from radio waves from the U.S. to let's say Europe? Okay, so folks say there's a underground fiber cable, right? The fiber optic. Cool beans. That's awesome.
Yeah, but most people don't even know that the first underground sea cable was laid, I think, it was the 1850s.
Exactly. Yeah.
I don't even know that.
I know.
1850 was the first, and I'm pretty sure it was somebody that's quick on a computer.
1850. Let's say
whoever's
1880s. 1880s.
Just type in first underground sea cable.
Yeah.
It was the first telecommunications.
1880s. They were doing that shit.
1850s. Yep.
Cool.
1858. That's when they laid the first cable.
Thank you.
Well, but not fiber optic, but underground sea cable.
Sea cable.
No, but telecommunications.
Absolutely.
So they could talk to one another across the earth.
Well, what I don't understand is why, if we can do everything on the ground, or we can do everything by balloons, which they'll acknowledge that's possible, would we decide that we're going to spend millions and billions and trillions of dollars shooting up equipment up into the atmosphere?
To try to do it from a space.
So we can believe in our worldview. So we can believe in our fantasy.
Because it's a story Arthur C. Clarke made up, and it sounded good, and it was a way for them to just keep propelling their space story.
There's nothing wrong with our sins. We want our sins. Let us have our fantasy.
What if space was real, and we had the engineers, the architects, the governments, and the money, the funding to actually go there? What do you think would actually happen?
Well, I think they've been there. I think they've been as high as they can get.
They keep saying they're going to go there. Like even their movies, right? Let's look at their movies.
They've tried
The Martian. What's the first thing Matt Damon? Hold on a second. What's the first thing Matt Damon did on The Martian when he got to Mars? He built a flipping greenhouse, a dome, a barrier.
I don't know. I didn't watch that movie, so.
Why is that their fantasy, though? That looks miserable.
Every space movie, when they go to a planet, they have to build a fucking dome, a greenhouse, a barrier.
What would be the objective? Like I just said, for the guy that's talking right now, like what the fuck? Why would we have to create this bullshit?
Oh, that's what I'm saying. They put it right in your face.
No, not you. The other guy.
Why did they create this bullshit about space?
Yes, sir. You.
So well, I think the big difference between. Hey, Aaron. Brandon. The big difference between the globe model and a flat plane or whatever it turns out to be is a globe model self-contained. It gives you everything in a nice little box, and it tells you that there's nothing else anywhere out there of any value, and that we're special on this little floating dust, but at the same time, we're not special. We're in the only place that will sustain life in the whole universe. There's nobody else out there, and it also makes us rely on them, the people who are telling us the story, and makes us stop asking questions about what else is out there.
Who are these people?
Well, I think you'd have to trace it back historically. We don't know exactly, but the people have been making up the story for the last 500 years is a good place to start.
Goddamn right.
The ones that are
media, right? The media.
The ones that are telling you you're in the Goldilocks zone.
That's right. Everyone is telling you exactly how to live for the past your life. Right?
They literally say that Earth is in the Goldilocks zone. Isn't that great?
Oh, that's very
Goldilocks zone. That's great. That's good.
It's good stuff right there. But at the same time, it's actually hitting home right now. They bring up all these enemies. They have to have an enemy. Okay. Number one was 911. Number two was the bank, 2008, the bank crash. Now it's 2020, and it's the virus. They have to.
Yeah, but that's just a recent, Aaron. I mean, they've been making up people for us to fight for as long as we can remember.
Exactly.
Somebody warned you guys about all that.
Meanwhile, they sit back and make money.
Oh yeah,
and have power.
They're banking big time on all this bullshit, panic buying, all this. It's just when you can see it. It's what do? We just live, right?
Stock market crashes, and then they can lose, buy it later cheap.
They set it up in a way that we are our highest power is them.
There's way more of us than them, right?
Have you considered
people need to get through their heads?
Have you considered a greater story is, I decided just to come back because the antagonist is gone and we're trying to get to the heart of matters. Have you considered that a greater story is sort of interwoven into the nature of our reality here? And, by us piecing the clues together as individuals, because that's all there is, right, is the individual, that we can sort of come to a greater understanding. Just when you talked about space, I mean, we're astronauts, right? Astronautical. Automatically, star and water presents itself. So if we're trying to figure out reality, I think in our own heads, we have to at least come to some sort of terms as to what does replace the vacuum of space. If you're just going to say, I don't know, well, then inquiry ends there, right? And any speculation beyond that will be on very shaky territory. I just say overall there is a greater story interwoven, and we have to sort of connect everything, right? Because nothing is separate from anything else. I've been talking about 9/11 and a symbolic hoax that it represents. It's the story of all of us. Remember, 9/11 was an inside job, right? So it's inside you, and reread the book of Job. Job is from a place called Uz, U-Z. Isn't that funny? It says Job is us, right? So, I think it's there for the individual to read. And people like Professor Bill, whatever his name, why do you even call him that? You know what I mean? But they do raise interesting questions. And remember, if you have something that is certain for you, for some people anyway, it requires sort of replacement before they'll step away from it. And if there's no answers forthcoming, it's easier just to stay where they're at.
Pete, you can stay on. Just you said a lot there, and folks want to chat a little bit.
But Pete, that's a good point, and it would be nice to have something that will replace it. But we don't know the answers. We've been in the dark for so long and told stories for so long, and we have very few people that we can trust. I don't want to just latch on to the next best story that comes along. We have to let the truth shine out and be discovered.
Yeah, I think to speculate about 9/11 is no different than to speculate on the shape of the Earth.
Yeah, or anything like what the sun is. We don't know what the sun is. We can't.
When you say
measure
we,
it's okay to think about it, but you
all we know is some evil took place.
But hang on, when you say we here, do you think the Navy, governments, do you think people really don't know what the sun is? Of course they do. They know the nature of everything.
They don't
have
it.
Yeah, but we know. We don't know. And they're not forthcoming in that information.
Pete, if they knew what the sun was,
Pete's question was, do you think they don't know, right?
Yeah. He said we don't know, and there was sort of a general consensus that we can, and there's an implication that we can't know these things, right?
The question was speculative. It was
of course it was, and then everything in our life is speculative. Of course it is.
Yeah.
So
and I'm saying there's a great thread, James.
If they knew what the sun was, they could make one, and that would be the ultimate.
Made one.
I think that's what CERN is about.
Listen to me real quick.
They have
that would be.
one.
Let me finish. That would be the ultimate weapon. When you say they made one, they're claiming they made one on a small, itty bitty scale. But if you can't make the sun,
how do you know the one you're looking at is not there?
Yeah, exactly. That's what I'm saying. How do you know? You can't say that you made a sun on a small scale. You got to make the sun.
But do you think you know these things, James? Are you just speculating? I think this is what CERN might be about as well.
Hold on. It's called reverse engineering. It's called reverse engineering. If the Germans crashed a plane in the United States territory, the United States military gets it. They reverse. Let me finish. They reverse engineer it, and if they think that technology is better, they steal that technology.
Cool.
Right?
So what are
in order to know what something is, you must be able to reverse engineer it.
Therefore, what are Germans?
That's not engineer.
You said Germans created something. What are
Germans? That doesn't logically follow, James.
Listen to me real quick, all right? It's called reverse engineering. if they knew what the sun was, they'd be able to make it. Just like if
he's on an awakening right now. I love it.
They claim they can make the sun in terms of atomic energy and atomic collisions, James.
You asked me to clarify,
hey, Pete,
and
let James finish, please.
I got a question for Pete. Sorry.
Let me finish. Reverse engineering, right? If you're the king of Rome or the United States, and the Germans crash something on your land, you confiscate it, reverse engineer it. If their technology is better than yours, you steal their technology and you know how to make it. So if you claim you know what the sun is, that means you must be able to reverse engineer it. You must be able to engineer it.
Well, maybe the sun isn't a thing, but it's something they can control. Like they can access whatever makes it brighter. Maybe that's what they control.
Can I interject? Can I interject with a thought here? I would like to interject with a thought based on a transmission and receiver concept, a reverse engineering idea. Does anybody here know what the glass plate of our human eye is made out of?
Yeah.
No.
Well, I understand it's called crystalline. It's a type of protein. This thing is so fucking hard and so solid that it doesn't even dissolve in acid. And based on the presupposition of the antenna receiver idea or the transmitter receiver idea, the sun, to me, when I research all the stuff way back when they've been 1800s, 1600s, all that stuff about the sun, I came to a sort of an understanding that it's very possible that it's a crystalline type of surface that the sun operates off of.
That's why when you die, like if old folks die, they shut their eyes or put silver dollars over their eyes because the eyes will still be open, right?
I don't know what that means, but anyway, I'm just saying it's as a transmission receiving type thing. I was looking at there's a society
that was to pay the coroner.
Exactly. Yeah. Not only that, your spirit was supposed to be paying the debt or paying to get into heaven, whatever. But
paying the ferryman.
Yeah. Well, everything in this life is a transmission receive, right? Yeah. Everything in this life is a transmission receive, right? This is what it is. Light is transmitting outward, coming inward to us, right? The tool that's built in our eye is built to receive that transmission, right? You follow me, everybody? So I'm just looking. I started researching this premise. Transmission receiving, and then I came across this Gong. It's Gong Society, G.O.N.G, and it's actually a society that's been around for a long time, and they are basically, to me, telling you the truth about the sun, and it's not a fiery gas ball. It's nothing that. It's a prismatic gong.
What do you say, or what do you think?
So it's basically what's running the world is sound. It's just low reverberation frequency. It's reverberating so low that it resonates upward, right? And that upward, well, that's what it is. Everything around us, light, sound. It's
God spoke the world into.
It's everything's transmission receiving, right? So
that's kind of like what Tesla said.
So what has replaced the vacuum of space in that?
Well, that's the thing, because if you look at what the evidence states, they're claiming that they can leave, right? They're claiming they can go through a barrier or whatnot. The issue is right now in Orion's site is that they have the radiation problem that everybody knows about. They can't pass the radiation belt, right? This is a common thing. I mean, everybody's reported on it. We're at this point where it's in the open, right? So I'm at a loss to even consider them even being able to leave, not just based on that idea alone, but based on the collected data that anybody can see. I mean, why wouldn't you go to another planet if you could? I know I could. I know that if I was a billionaire and I had lots of money, I would. But what would be better? What would be better is that it would be less expensive to go, and I'd make a ton of money on the idea. So
man, they got robots. They got robots in the desert. I mean, on Mars.
Well, I used to believe that. Until I actually researched the laws of nature. The funny thing is, I never actually. The suspension of disbelief was so grand that whatever really it started to get absurd when I saw the article that it was raining diamonds on Uranus.
You see that, dude?
So when I saw that,
this is before. Could you quit looking at my anus?
Yeah, exactly right. But it's just got more and more absurd as we went. But anyway, going back to the transmission receiving type thing with the prismatic gong, this company, whatever, go look at it, gong. They literally have a new
pulling shit out of their ass.
Well, no, man, because there's a resonance, right? There's the Schumer's resonance or whatever it's called. It's the guy that discovered the Earth hum.
Okay.
So, the Schumann resonance.
Yeah, so there is evidence of that. Now, we know that shooting of crystal with sound can cause energy, right? We know that scientifically we can actually shoot crystals with sound and it produces energy. Yeah. So there's a lot of things that we're not equating to just the transmission receiving idea, because we're transmitting a thing to the stone and the stone is reacting to it. It's actually the process inside it. So we're built to receive things, right?
Yeah. Exactly.
So the transmission is only really three. There's only three things really. It's the light, the sound, and the vibration of it all, right? So
what is the source then?
Can give you.
Well, that's the thing. Hold on. The sound is God. The sound has to be God.
Flat Earth can we
in water frequency can give you light.
Yes,
and they found too that our brain doesn't hold memories in a certain place. Our brain is a receiver.
Sorry, Paige.
Yeah, our brain receives information that has already been created.
How do you know this? How do you know the sound is not the sound of the tides?
I would love to hear
the sound is not the sound of the what?
Does that not make a lot more sense that the sound of the water moving around us, all the tidal movements?
It was like the sound of the earth?
It could be. It could make sense like that. If you listen to the ocean at night, of course, when it's all quiet, and you listen to that on a large collective scale, that sound could be the Schumer's resonance. It could be the low hum of the oceans for sure. Absolutely. I see that totally plausible now. Yeah. For 100%.
I would love to hear. I would love to hear Pete's response to Flat Earth Data's, excerpt right there. If Pete wants to.
Just briefly, that's why I asked what is replaced the vacuum of space in this model in this system. I would also like to ask, have you honed in on a source? I mean, it all comes back to what Earth actually is, right? And what the skylights are in relation to us. So, I think I generally agree with you. I'd also say about the glass you mentioned in the eye. Of course, glass can be made out of sand, and we all have a natural frequency.
Yeah, but this sand can be broken down in acid.
Composition of our matter, right? Yeah. What?
So,
go ahead.
You almost got the fin.
Flat Earth Data, can I ask you a question about what you just said? It kind of sounded like you were describing us and the mechanisms that we live in as a form of technology.
Almost. Well, isn't it? Isn't it?
Yeah.
Absolutely, it is. For sure, it is. 100%.
It is.
It's designed elegantly. I mean, I think you can maybe look at this as a loosely understanding of why some genetics are different than others, and I mean, I think man can exploit that the genetic fault in a human, but I think it's an inherited, or it's a byproduct of the inheritance of the people before you, and the people before you were, depending on where you live, were either respectful of the land or were destructive of the land. And I think people who end up with disabilities or issues are precedented in daily life by the people before them. And
I was just going to say, do you take because when we come to flat Earth, right, we look back at history, everything comes under the microscope. So, I mean, do you accept some sort of official timeline, and do you base your thinking on that evolution?
Well, do you know what blows my mind is that when I watched a video, I think it was UAP that did it, perhaps, maybe. It was on coins and the establishment of money. And I found it really interesting that a lot of the coins were early 1800s. Yeah. And if you think even in the 1600s, like Newton was the first tax collector, right? He was actually
No, he wasn't. No, he
Newton was Britain's first tax collector, bro. Newton
He
was,
was
yeah.
the mint. It was something to do with the mint. Yeah.
Yeah, he was a tax collector. He would actually go around murdering people. So, well, sorry, he was not only the tax collector, he was a fraud investigator. He was supposed to be checking whether or not they were making fraudulent coins and all that stuff. And if you did, he'd kill you.
Yeah.
So this is part of the history. Anyway, when you look back, there's definitely owners that bought the United States in the early 20s.
Sure.
It was
I don't think Newton existed, by the way.
Yeah.
What did?
Yeah.
Newton. I don't think Newton existed. I think it's more storytelling.
Newton who? Newton who?
Well, here's the thing. Like if you read, there's supposedly 169 books that he wrote about alchemy.
Read it. Yeah, if I read it.
Right?
Yeah.
There's supposed to be diaries. Like in his diaries, he talked about how much he hated God and how much he wanted to kill his parents.
Okay, cool. So what effect does it have on me today, Flat Earth Data?
On knowing about Newton's background? Maybe it's just entertainment. I mean, everybody likes an entertainment now and again, right?
Well, what you should be saying is Newton himself said, "Do not ascribe innate gravity to me."
Yeah, exactly.
Yeah. Literally, I'll paraphrase him, but he said that you'd have to philosophically, with any sort of competent faculty of thinking, you'd have to be a fool to believe it.
Yeah. When you talk about Newton and money, to me, that's total disconnect. I think Newton, gravity, mass attracts mass. That's what I think. MG, like that. When you talk about
wait a
Newton
sec, though,
and money,
yeah,
I'm done.
But when you look back in the early 1500s, 1400s, and all that stuff, there is written material. There's unless you're willing to commit to the idea that it's a complete fraud, I don't think that's genuine. I think that would
there's articles. There's articles in the New York
I know, but
Times.
it would take away the fact that we have a calendar, or sorry, we have a year, like the year system set up by a philosophy, like an idea of Christ dying, right? This is really how the whole system's set up. And if you look at the foundation of where it all came from, like the growth of it came from the commitment to Christ. That's why we have all the institutions we have. And now, if you look at
how corrupt they are, bud.
Well, now they are. But I think when they first started out, I don't think. I mean, of course, there's history of certain.
It didn't actually come from Christ.
No, but if you listen to what I'm saying, like all the foundations in the school system set up, I understand you have to control a populace as an institute, a government, right? You have to figure out a plan. But if you look at what was built, we have fresh running water, we have grocery stores. There's a good, is what I'm saying, right?
Yes,
so
the system is good.
So listen, hold on. Let me get it out.
Let me tell you what they did.
We could have all personal flying saucers.
Before
we have toilet rolls at the local shop.
I'm talking in the beginning. I'm talking about the beginning. There was a pursuit. There was a liberty in a set for the person to have pursuit of happiness and the fulfillment of God. That was their initial goal here, right?
We have that. We have that.
Yeah, I know. We still have the autonomy.
I have power. I have everything I need. It is God's creation on earth. I have power. I have water. I have everything I need. So, Flat Earth Data, what do you mean about the next step?
What do you mean the next step? Like in reference to?
Yeah, about.
When it comes to truth, there is no next.
So what I'm saying is, for me, when I look at history, because we were discounting the idea that, or we were discounting history, it was all created, made up, as Pete Shea referred to in the beginning.
Let's say it's all a construct, man. Let's say it's all a construct at a very young age.
Yeah, I get it, but see, if you look at the coins, really something fascinating happened in the 1800s, right? You had like this institution of science and institution of religion, and it was like this attitude to conquer mankind, where we came from, who we were, and then it evolved, right? And so I think there was a genuine respect for the creation around us at this point in time, because when you read the literature, there's bad apples in there for sure, but fundamentally it was about building a town so people could live well and have running water, and of course there was always a businessman willing to invest in these things, but it would be. I'm just talking about the negating history as it's irrelevant. It's a complete
You're taking
construct.
That's an actual starting point, and that's an actual evolution. I don't trust it, though.
Well, I'm saying is that if you look at the growth of it, there's no going back. The only reset are the civilizations that were completely wiped out for some supposed unreason. But then again, we're getting provided that information by the powers that be. The point is when you actually look at monetary things, there is history for North America and Europe that you can, there's tangibility there. There's artifacts there.
Sure.
The point is there is, to me, there's a gap. Like the Dark Ages and the Middle Ages, I don't think existed. I don't think there was anything like that.
So if this is a construct and we're some kind of technology and it was built for a purpose, obviously, what possible purpose or gain would there be to have us here to grow the human population?
Well, the thing is that the Earth is very, very large. It's not even close to being overpopulated, in my opinion. It's a drop in the bucket compared to how big Earth is. What I think the Earth, what this is for, that's the personal journey for me, and it's probably different from everybody else here, obviously.
Sure.
For me, when I look at the surroundings and what's been constructed here, we're building turbine engines. We can travel I can be in Mexico in 8 hours from where I'm at, and have the decadence, the decadence style that we have is at the cream of the crop, and I think it's the highlight of any recorded history that we know in present time. What the purpose of that is? Well, the narrative that I'm growing up with is that there's two paradigms you can choose. You can choose the paradigm that you evolved out of a singularity, Big Bang, into primordial soup of electricity, or there's a creator that manifested Adam and Eve. I mean, it's really these two paradigms that were presented to me. I wasn't born in this world writing anything, although they've given you an opportunity to write your own story, write your own religion, write your own, whatever it is, right? That's the whole point.
You can write anything you want, but will it be published?
No. I mean, in general,
FED, right here, real quick. What do you think about the Industrial Revolution? What was that?
So the interesting part about the Industrial Revolution is obviously the beginning of the automotive industry and manufacture, like what do you call it? Mass production.
Global.
Well, mass production. Well, yeah. I mean, it's. What do you want? There was, like I said, in the 1800s. If you go look, there was an explosion. There was, people were paid to make things up. People were paid tons of money. I'm at a loss right now as an example, but basically this, like you have different models of the Earth, right? People were actually paid to come up with models back then. They were paid to have theories and test these theories and claims, right? So there was a major.
Well, that hasn't changed.
Industrial Revolution.
It has changed because what happens now. Listen, what happens now is most people are stuck behind computers and they're not tinkering with things like Faraday did or Tesla did. People aren't doing. Listen. If you understood that you can actually get the air is surrounded full of tones. You can't hear these tones, but you get little transistors and receivers. You can tune into these tones. Okay, when you tune into these tones, you can get free energy. You can get basically free energy.
Let me ask you or the panel. When did the Industrial Revolution happen? Let's say from Europe to the U.S. Right?
So the 1970s.
It was 1790, right?
Yeah, it was 1800s, man. It was the 1800s. Yeah. So like I said.
Okay, so now let me ask you, when was the first globe created?
So 1492 was the decorative. There's a guy that made the decorative ball in 1492. It was in the household. Well, for my story, for my research, it was put in the household of the rich as a decorative piece where they held their alcohol.
This century, last century, sometime, right?
No, it was early. It was a decorative piece in the early 1400s.
1492. 1492.
So you were saying that they used to tinker and come up with different
We don't
models.
tinker.
And they'd be
We don't
paid
tinker
for it.
anymore. We don't.
Why?
Listen, man.
Why'd we stop tinkering?
Because we got a TV in front of us, man. Listen. I'm guilty here. I don't know if anybody who can be honest. Sometimes you just don't want to think because you're given the option not to. So you watch TV or watch a show. Tesla wasn't given that opportunity. You know, he didn't. There was just one or the other. I had to work with my hands or I had to work with my mind.
Prove Tesla existed.
Hang on.
Prove Tesla existed.
1 second.
Tesla gave you the TV.
What would be a practical reason for having a map on a globe?
What would be the practical reason for having a map on the globe? Well, people want to see
think
the
about
global.
The year. Think about
people.
One
People
second.
want to see the
Second.
global.
It wouldn't be
People-
practical.
Think about the question. Think about the year that it was. Think about the year, right? That it
What's
was
that?
supposedly the first globe, right? 1492.
It was Columbus when he told the Queen that for sure, or Magellan. Sorry, it was Magellan that he said to the Queen, "Yeah, I'm going to go out. I'm going to come back and watch. I'll come back. There's round." That's literally basically what happened. And then he got mutiny or killed, basically 3/4 through his trip or something. And then the other fucking guy took over, and he got
yeah. We learned that in primary school, Fed. We learned that in primary school.
I wouldn't believe that so.
Who has more?
Not you. I'm not saying you're a lawyer or anything. I'm just saying I wouldn't believe.
Who has more written documents, Christopher Columbus or Jesus Christ?
1 second.
I don't actually. You know what? I would assume that Jesus Christ changed the system. And had a major impact on the system, and I would say Columbus, ironically, had a major impact on the system.
So both of those men
I had a reason for asking what I asked.
Is your calendar based off before Columbus or after Columbus?
So Constantine, right when he died, he added 2 extra months.
Or is it based off before Christ and after Christ?
Well, it's before and after Christ. It's originally that's what it comes from. So
they tried to change it. A lot of power, James.
So of all the religions, there's only one that your calendar is based off of.
Yeah, well, the church do have a lot of power, James. That's true.
So the Roman
vested interests over the years, James.
I wonder what's going.
The Romans.
You know the same people who are ruling things right now, James, making it difficult for everyone.
The same ones that are against Christ.
Okay. Yeah, they gave us the story and encourage us to think literally about these characters, but we don't question whether they existed in the first place, right? Or we don't question if there's a deeper symbolism to these characters that relates to our real story right now that we're trying to figure out.
There's too many documents.
I agree with Pete. We don't even know if Tesla was a real person. All you see is these pictures. Like, I take the same stance. Bro,
when was Tesla born and when did he die?
Never met him.
Yeah.
Oh,
well, I agree. I agree. And now we're getting to hear about Tesla. Hang on, please.
I know.
Let me just say this. As flat earthers, now we're getting to hear about Tesla everywhere, and we see that he's the true hero, and we all know that Einstein now is a fraud, right? So yeah, we're being set and led at every hand's turn here.
There's more evidence of giants than there is.
You guys kidding me, man? You're talking about when we're all dead. And five generations from now, people are like, "Well, did Pete Shea ever really exist?" Are you fucking kidding? That's what you're
giving.
Yeah. What are you talking about, James?
You're given Tesla by the same people that gave you the ball Earth.
Yeah.
Yeah, and those same people tell you they control both sides.
It's very hard to trust any information.
Yeah, but the difference is though they didn't really teach Tesla in school. They didn't tell you that Edison electrocuted elephants on the street. They told you Edison was a genius. So they actually avoided Tesla.
Story too.
I've seen the footage, dude. I've seen the footage.
Bro,
I've seen the footage.
They ripped that
You're dealing with fools here with flatter data.
I've seen Edison's footage, dude.
For you. Fake a birth and death. Very hard to fake a birth and a death.
The globe was created.
That's hard to fake.
Pete, the globe was created at a point where industrial movement across the seas, that's where they had to create the globe. They had to create it.
Yeah.
Because
I would agree.
Yes, because commerce, corporations cannot exist on the flat earth. That's where we exist. They can't do that, right?
I would say as well, though, there's a greater story in play here, and I look upon the spinning ball now as metaphoric. As we talk about the wonder, the miracle that is our human body, first of all, I would like to ask Flat Earth Data, when you look at nature around you or describe nature, do you not see a wasteland? Do you not see a broken system?
Yes.
You're asking me if I see a wasteland? What I see is a beautiful creation that's completely hijacked. And what I also
talking about
see
is the layout of the land itself, not the structure of society.
That can be considered broken.
I see. Well, yeah, of course. When you see the society around it, I want no part of it. I want a house in the woods.
But
talking about the earth itself, man. Listen, please. I'm talking about the earth itself and the nature of the earth. It goes back to the nature of us ourselves. Are we in our true natural form? I say we're all divided male from female, literally, right? And maybe the ultimate purpose of this is understanding the miracle that is us and the ability that is us to piece things together. Maybe that's the whole purpose of life. You talk back to thousands of years ago or hundreds of years ago as if you can vouch for it, as if it was yesterday. James asked a silly question there. In 5 generations, will they look back and question whether Pete Shea existed? Well, James, you can vouch for it right now, right? And that's all there is right now. And I don't think we have 5 generations anyway. Let me just say before I go, I know I can talk, right? Let me just say before I go.
Listen, it depends on how you think about where the earth comes from.
Hold on. Let me defend myself. The whole reason I asked it, Pete, is because you're questioning if people that you read about existed.
Sure.
All right. So what where do you go from there?
It's your
we're here
statement.
right now,
go
James.
For it. That's right.
We're here right now, and I'll vouch that you exist as a man. I've seen you on camera, and you'll do the same for me. When it comes to Columbus or Jesus 2,000 years ago, fucking hell, I'm 48. That's a long time to consider. So I can't say anything for definite. I found out everything else is a lie. I've also seen the symbolic. I've also seen the symbolic.
More question, Pete. Why do you think? Pete, why do you think the Earth is? Pete, why do you think the Earth is a wasteland?
Because it is, man. We live on. Look, have you seen the No Forest? Hang on, please.
Pete,
the No Forest and Flat Earth video.
Before you answer that, realize the question. Say again the question, please.
Why do you think Earth is a wasteland?
Yeah. Okay. Because I do. I say it's in a destroyed, collapsed state. If you've seen the film No Forest on Flat Earth, that was given to us on a plate as well. We're supposed to follow these clues. When you see that, I've pointed out to anyone, we all have Google Earth. We're given these facilities. Go on Google Earth. Pick an island like the Isle of Man or Ireland or something like that. Go a mile off the coast, right? And go all the way around the island in sort of double quick time. By the end of that, if you don't tell me you're living on a tree stump of some sort or some nature, well, you're not, there's something wrong with you because there's no clear example.
I get that. No, I get that. Because you can look at science.
Yes, I am.
Look at science and science.
Oh, you're right. Someone remove me from the call.
Yeah, it's fine.
Yeah,
it's fine.
Same when someone removed me too, but you can look at previous records, like at least going back a few thousand years, if you take any of that consideration. There appears to be higher concentration of oxygen in our atmosphere at one point. So this would explain larger humans, larger trees, right? To me, that's what the history says. When I look around, I can see things that are bigger than me. If I go there, I look at a mountain, sometimes I can see a face in a fucking mountain. I know that's a little far-fetched, but I'm saying in general, you can look at
plenty of evidence of that.
Exactly. That's what I'm saying. So when I see that,
are big vaginas and
exactly. So when I I know that.
Well,
when you see no, I agree with you, but I have to laugh because if you anybody know about the fossilization process? When they do make even carbon, into diamonds and such.
It makes it quickly, like within a couple of weeks, you can fossilize something.
Well, that's what I mean.
I think there's a deeper metaphysical story being played out here. And when Page talks about vaginas in the rock structure, absolutely. Look at Africa and you'll see the massive leviathan and serpent. Look at the clouds in the sky. I tell you to pay attention to your local clouds.
Yeah.
We're coming into the sort of the end times. And the dragon is here. How long have I been saying the dragon is here? Well, the dragon is fucking here, friends. Whatever it means. All the illusion has the shadow, right? It has to.
So what do you think the purpose of us having less oxygen and having an environment that we regrow in that we're smaller. What do you think the purpose would that be, Pete?
What do you think the opposite would be? Right?
Oxygen is a poison. We live in a broken system, right? Under repair. So ultimately, our true natures, right, and our true abilities, I think they will come to shine. It's written into the book of life, right? I do hold the creators in my life, right? So there's a purpose behind all of this. And that's why I asked the question earlier on. I'll just say this. That's why I asked the question earlier on. Have you considered as a sort of a seasoned flat earther that is a greater sort of mystery story interwoven into everything that we're sort of coming by, and this greater sort of puzzle to be pieced together? After all, Mark Sargent told us what he's clues,
Pete,
right?
Pete,
I didn't watch his. I didn't watch his clues actually.
You never watched his clues?
You know what? The only time I've ever seen him is on interviews. I never paid for his subscription. And I never joined him. I actually when he
I just want to say too, I didn't remove anybody. It wasn't me that did that. So.
I say most people have missed Mark Sargent's real clues. Mark Sargent's prepper, right?
Well, listen, Metatron's really important there, Pete. I don't know if you looked into Metatron yet.
Metatron is Enoch, right?
No, Metatron is the Kabbalah.
Right, guys, I am gonna hit the hay right now. I've been going for over 4 hours, and I am tired. But I will record for as long as these guys want to record for. And if they do an hour or so, I wouldn't mind uploading it tomorrow. But yeah, I will be live tomorrow as well. So yeah, with that, thank you, Professor Phil Bell, for coming on and spending a good 3.5 hours there, and for all the panelists for joining too. But we have quite a few in the chat right now. Sorry, in the panel right now, so it's kind of like tight to sort of end it right now. So I'm going to end the stream, but I will keep recording. So I'll see you all in the next one.